Hello, hello, hello. So here, I'm sorry for not being able to take this session on Saturday, and in fact not on even on Monday because of some issues. But today we are going to start with the next part of our algebra session, where we are solving all the good questions which are expected to come in our JEE Mains attempt 2 from algebra part. So today we'll be focusing on binomial theorem as well as our matrices, determinants, and even complex number a little bit. Alright, so let's start. Some really good questions are there with us from the chapter of binomial theorem, right? So I think out of these somewhere around 18 to 20 to 22 questions will be there from binomial theorem, and these are really important. I think if nothing else, then at least these you should practice, you should listen to, so that from binomial theorem is a very high weighted chapter and is considered to be a calculative and difficult chapter. So these questions I'll try that I can impart the perfect thing, whatever you need to solve these questions in time and minimize your calculations. So those things I'm going to tell you. Let's start. Hi Sukhi Baba, how are you? Hi Vijaya. All good? Okay, so we saw last binomial theorem. Very important thing in the entire chapter actually, right? Most of the things we know, like for example NCR divided by NCR minus 1 if we have, then we know this is N minus R plus 1 divided by R, right? These important formulas, all of them we should know, right? For one more very important and applicable everywhere is this one. For NCR can be written as N by R, N minus 1 C R minus 1. Right? These two will be frequently used. These two things are frequently used in the questions, right? So remember them, keep them handy. Wherever you see, for example, suppose you see NCK plus 1 or NCR plus 1 divided by NCR. This is also of the same form, right? NCR upon one less than the upper one. So this is also same. So you have to be very quick in analyzing. Yeah, this is going to be used. Apart from that, some summation formulas, many summation questions we have seen which come in your binomial theorem questions, right? Many times summation questions. So summation I would say at this point of time directly remember, although these can be derived very easily with the help of differentiation, sometimes with the expansion series, sometimes with integration. For example, this formula generally we derive with integration, these two by derivating 1 plus x to the power n only, right? So summation of coefficients, different forms of coefficient, for example summation of R NCR will be equal to n multiplied with 2 to the power n minus 1. R is starting from 1 to n. Summation of R square NCR, will be n multiplied with n plus 1 multiplied with 2 to the power n minus 2. I think you can remember it like this, differentiate it once again. So n into n plus 1 will come over here, right? Or you can remember it with the help of formula of sum of first natural squares, right? N into n plus 1 multiplied with 2 to the power n minus 2, then this one. These three I think you should remember, otherwise if you go on deriving, or you'll get stuck. If you start solving also these parts under the summation and then form the summation, then it will become very difficult. So remember these at least for binomial theorem. NCR upon R plus 1, many times I've seen in JEE Mains questions, this is directly used, but students do tend to leave that question or solve it in another way. So it's better that we remember. Summation of NCR divided by R plus 1 is simply 2 to the power n plus 1 minus 1. This minus 1 is separate, divided by n plus 1. Okay, this is one thing. Then this is not that important. This okay, even if you don't remember, because this will come as last form only, which you can do. This one, summation of NCR whole square. Yes, this can also, a direct question can come on this. So direct question can be solved by those students only who can remember this. 2n cn. This summation will always be equal to 2n cn. R is starting from 1 to n. In the third and fourth formula, remember R is starting from 0 to n. Okay. In rest all of them R is starting from 1 to n. Here also 1 to n. Right. NCR whole square summation will be 2n cn. Remember this. Okay. Now let's jump on to the questions. Okay. Some questions which are from the current year only, they have the highest chance of repeating, or that concept or that particular part of the chapter has the highest chance of repeating the questions from this year and last year. So most of the questions either are similar to this year questions, right? And some of them are as it is PYQs. This question also appeared this year only for us. What does the question say? Suppose A and B are the coefficients of 30th and 12th terms respectively in the binomial expansion of 1 plus x to the power 2n minus 1. Right? If 2a is equal to 5b, then n is equal to what? Now, how to solve this question? Let's start solving this question. Coefficients of 30th and 12th term. Now, we know that coefficient of 30th term will be NC30 minus 1, right? NC30 minus 1, that means NC29 will be the coefficient in this, right? But what is n? N is 2n minus 1. So, 2n minus 1, C29, right? Coefficients. This is the coefficient. Only this is the coefficient. And 12th term coefficient will be 2n minus 1, C11. These will be the coefficients of 30th and 12th term. This is how we are supposed to write. Now, 2a is equal to 5b. That means 2 times of this is equal to 5 times of this. That's it. Now, we can open these things up. So, let's 2 multiplied with 2n minus 1 factorial divided by 2n minus 1 minus 29. That means 2n minus 30 factorial multiplied with 29 factorial. NCR factorial, NCR is n factorial upon n minus r factorial multiplied with r factorial, we know, right? Now 5 multiplied with 2n minus 1 factorial again divided by 2n minus 1 minus 11, that means 2n minus 12 factorial multiplied with 11 factorial. Okay. Now 2n minus 1 factorial and 2n minus 1 factorial will go directly without any trouble. And now 2n minus 30 factorial also we can cancel with 2n minus 12, no? Right? 2n minus 30 factorial, sorry, 2n minus 12 factorial will be 2n minus 12 into 2n minus 13 into 2n minus, like this it will go, right? How will this go? This will go as 2n minus 12 into 2n minus 13 into 2n minus 14 into 2n minus 15, like that, right? So this factorial you can write over here. Now let's bring 2 multiplied with 2n minus 12 factorial. Let's say we can simply bring it like this, multiplied with 11 factorial. Let's say, okay, 2n minus 30 and factorial multiplied with 29 factorial. Okay, now cancel out things. So this is multiplied with 5 also. This is multiplied with 5 also. Now 29 factorial. In 29 factorial, if we bring this term over here and rest everything over there. Now what I'm going to do, 2n minus 12 factorial divided by 2n minus 30 factorial is equal to everything else on that side. 29 factorial 29 factorial multiplied with 5 divided by 2 multiplied with 11 factorial. This is how I'm going to, let me put it on silent only. So this is going to be the scenario. Now 2n minus 12 upon, so this I can write as 2n minus 12 will be 2n minus 12 into 2n minus 13 into 2n minus 14, like that it will go, right? Or we can cancel 2n minus 12 to 2n minus 29 it will go, right? Right. 2n minus 12 factorial will be moving like this, 2n minus 12 minus 2n minus 13, n into n minus 1 into n minus 2 into n minus 3. This is how it goes, right? 2n minus 12 into 2n minus 13 into 2n minus 14 into 2n minus 15. It will go till 2n minus 29, right? And then 2n minus 30 factorial. After that, 2n minus 30 factorial will be included. In division, what do we have? In division, we have 2n minus 30 factorial only. This thing only we have, right? So this and this will get cancelled. What will we have? 2n minus 12 multiplied with 2n minus 13, and this is going till 2n minus 29. Correct. On the right side, what do we have? On the right side, we have 29 factorial multiplied with 5 divided by 2 into 11 factorial. Right, 29 factorial will be 29 into 28 into 27. This will go till 12, and then 11 factorial we can multiply. In division, we have 11 factorial multiplied with 2, and above there is 5. There is a 5, only 5 over here. 11 factorial multiplied with 2. So this 11 factorial will go. Now you see 2n minus till 2n minus 29. How many terms are there? How many terms are there, including 12 and 29? 29 minus 12, 17 plus 1, 18 terms are on this side, right? There are total 18 terms, including 12 and 29. Over here, how many terms do we have? Achha, this side, if we observe carefully, 29 into 28 into 27, this will go. Now, this 12 will get multiplied with 5, and this will get divided by 2. So, 2, 6 are 12, will have 30. So, this side will become 30 multiplied with 29 multiplied with 28, and this will go till 13. Now, 30 to 13, how many terms are there, including 30 and 13 both? So, 30 minus 13, right, which will be 17 plus 1, 18, right? Whenever we have to include both the terms, we have to add 1 in the difference, remember that. Now, this side also 18 terms, this side also 18 terms. That means this product is equal. We can equate anything. We can say 2n. You can say 2n minus 13 is equal to 29, or you can say 2n minus 14 is equal to 28. Or you can simply say 2n minus 12 is equal to 30. So, n will be equal to 42 divided by 2, that is 21. Directly, n will come. So, always be confident in solving the NCR thing. If nothing works, solving will work if you are confident and practiced with the solving part of NCR. Okay, let's come upon to the next variety of question. This is one variety where they'll ask you n, they'll give you some equation or some coefficient related problem. This is one variety of problem which is repeating again and again. Now, in the this is also the coefficients, right? Coefficients and comparison, and they'll ask you something related to that. For example, in this question, 1 plus x to the power p multiplied with 1 minus x to the power q. The coefficient of x and x square are 1 and minus 2 respectively. Then tell me the value of p square plus q square. Come on, try solving it. So, 1 plus x to the power p, 1 plus x to the power of p multiplied with 1 minus x to the power of q. Pay attention. Expand it, right? How do we calculate the coefficient? How do we calculate the coefficient? We'll expand and check what are going to be the coefficients of x and x square. Be very basic. Don't try to apply any tricks and all, because JEE always knows the tricks. They'll always play with you on the tricks. Okay. You should remember the basic formulas and everything, but many tricks are there on the internet. I won't recommend that you apply those tricks. Many of them are wrong also, don't work in many questions. Now, how will we do this? We'll simply see the expansion, observe the expansion. For example, expansion of this part will be PC0, 1 to the power p, x to the power 0. So, only 1 to the power p will be 1, x to the power 0 will be 1 only, plus PC1, 1 to the power anything, be it anything, x to the power 1, plus PC2, x square, plus PC3, x cube. It will go like this. It will keep going on like this. Now here, now I just need x square. So, I will not expand more than x square. Actually, this term also I shouldn't write. Now, next thing, 1 minus x to the power q. So, this will be qc0 minus qc1 x plus qc2 x square, right? And minus qc3, one more term, let me write x cube. Although you don't need to write, this will keep going on like this. Okay. Now you see how will we be able to generate x and x square using the multiplication. Now, in which cases we are getting x square? Let me write it more. 1 plus PC1x plus PC2x square. Okay. And this will be 1 minus QC1x plus QC2x square. It will keep going on like this. Now observe, where are you getting x square? 1 multiplied with 1, not giving you x square. Okay, first let's concentrate on x. Where will you get x? 1 multiplied with minus x. 1 multiplied with minus QC1 into x will give you a coefficient of x, right? So 1 multiplied with minus QC1 into x will give you a coefficient of x. Then this one multiplied with PC1 into x, yes, plus 1 multiplied with PC1 into x. This is also giving you an x. Any other way of getting an x? No, right? No other way of getting an x. So this is the only way. And what is this? 1 multiplied with QC1 plus 1 multiplied with PC1. PC1 is P, QC1 is Q. So we are simply getting P minus Q over here. And P minus Q, the coefficient of x is given to us equal to 1. This is given to us equal to 1. One equation generated. P square plus Q square we want to tell. So we'll need PQ also. We'll have to compare x square coefficient also. Now x square, this is for x. Now let's go for x square. Coefficient of x square. When will x square be generated? 1 multiplied with QC2 will give you x square, and this one multiplied with PC2 will give you x square. So we can say PC2 plus QC2 multiplied with x square. Directly we can write like this, no? PC2 multiplied with 1 and QC2 multiplied with 1 are going to give us x square. How else are we going to get x square? PC1 multiplied with Q. PC1 into x multiplied with QC1 into x. This will also generate x square. X into x, x square. So minus PC1 into QC1. Why minus? Because plus into minus into x square, right? X square coefficient will be this. So that means coefficient that we have is PC2 plus QC2 minus PQ. This is equal to my minus 2. This is given to me equal to minus 2. Okay. So this we can solve PC2 plus QC2 minus PQ. PC2 plus QC2, correct. PC2 plus QC2 minus PQ is equal to minus 2, right? Minus 2, right, is equal to minus of 2. So this we can solve P factorial divided by P minus 2 factorial multiplied with 2 factorial plus Q factorial divided by Q minus 2 factorial multiplied with 2 factorial minus PQ, right? Now this is P factorial means P into P minus 1 into P minus 2 factorial. P into P minus 1 into P minus 2 factorial. So here what we will get, P into P minus 1 will remain on the top, divided by 2 we will get P minus 2 factorial, and P minus 2 factorial got cancelled over here. Here also Q into Q minus 1 divided by 2 is minus PQ is equal to minus 2. So one equation is getting formed, one equation is forming from here. What are we having? P square minus P plus Q square minus Q is equal to 2PQ minus 4, right? This PQ will go that side, 2 will go that side, multiply, and this equation will be generated. Now what do we know? P minus Q is equal to 1, right? We know that P minus Q, let's write it like this, P square plus Q square minus 2 minus P plus Q is equal to 2PQ. This is PQ, 2PQ minus 4. Now one equation we already have, P minus Q equal to 1. If we square it, P square plus Q square minus 2PQ is equal to 1 we are getting on squaring both the sides. Now just find any value, P 2PQ you can find. Either you can use P plus Q whole square is equal to P minus Q whole square plus 4PQ, anything, any way you can solve with your own way. Most naive way which I am telling you is that you find 2PQ, right? 2PQ will be equal to P square plus Q square minus 1, right? 2PQ will be equal to P, or what we can do is, we can find, instead of P square plus Q square, we can put 1 plus 2PQ. So 1 plus 2PQ minus P plus Q is equal to 2PQ minus 4. So this 2PQ is getting cancelled, and we are getting P plus Q value equal to 5. Correct? P plus Q is coming equal to 5. P minus Q is equal to 1. P and Q both have to be integers. So this is simple that P will be equal to 3 and Q will be equal to 2. Only in that case it can happen. Positive integers they have to be, right? P will be equal to 3, Q will be equal to 2 then. So P and Q value directly we found, and P square plus Q square. Now we can find, which was asked to find. 9 plus 4, 13 will be our answer. 13 will come out to be our answer, right? Simply solved. But you have to be very quick. Many steps I've written which you don't have to write. Now this year generally they ask rational terms in case of questions like this: 7 to the power 1 by 3 plus 5 to the power 1 by 4 to the whole power 30 something they'll give you, and then they'll ask you what is the number of rational terms in this, right? And we'll have such questions also, but first I want to discuss this particular question, which is from the multinomial theorem. This question is from multinomial theorem. Without multinomial theorem also we can solve it by taking these two as one term and this is another term, but it will take a lot of calculation. So that is not the suggested approach of solving. Okay, what is multinomial theorem? Simply x plus y plus z to the power n is given by n factorial divided by r factorial, s factorial, t factorial, right? And here x to the power r, y to the power s, z to the power t will be there. And always for r plus s plus t will always be equal to n. This is. And also know one more thing about this multinomial theorem, which is sometimes asked directly. What will be the number of terms in this? So number of terms we derive by the distribution method that we learn in PNC, permutations and combinations. How to distribute n things in 3 people, right? N identical things in 3 people, that part, which comes out as n plus r minus 1 cr minus 1. So here n plus 3 minus 1 c3 minus 1 will come. That means n plus 2 c2 will be the number of terms, in multinomial expansion. Know this directly. Sometimes they ask you questions directly based on this. How many terms will be there in the expansion of this? Okay. So that won't be 6 plus 1, right? Don't directly write 7. It will be n plus 2 c2, right? Direct question can come on this. Now about this question. Okay. This I am removing. You must note or pause and note, right? Now this question, for example, n is 6, so 6 factorial divided by r factorial, s factorial, t factorial multiplied with 1 to the power r, 2 to the power s by 3, correct? 2 to the power s, this is y, 2 to the power s by 3 multiplied with t to the power of t by 2. Okay. Now rational terms we want, right? We want rational terms. So we know that r plus s plus t should be equal to 6 first of all. R plus s plus t should be equal to 6. And now here s and t should be for rational terms. For rational terms, your s should be the multiple of 3 and t should be the multiple of 2. Correct? So you'll have to derive all the scenarios in which this can happen. Now let's see when can it happen. R, S and T. When R is 0, S is also 0, T is 6. This is okay. 0 is multiple of every number. So 0, 0, 6 can happen. Acha, 6, 0, 0 can happen. Okay, 0, 6, 0 can happen. These 3 cases. One, R can be 0, no problem. R can be 6 also, no problem. Right? S can be 0, T can be 0. All 3 can be 0, not a problem at all. In that case also it will happen. Now what else can I take over here? 4 and 2 is also 6. 4 and 2 is also equal to 6. But 4 cannot come in the place of S because 4 is not a multiple of 3. So either R can be 2 and T can be 4, or R can be 4, T can be 2. Right? This will be 0 in both the cases. because 4 is not a multiple of 3, obviously. Now what else can we take? 1, 2, 3, 4, 5. One more, I think 2 more cases should also form. How else can we get 3, 3, right? 3, 3. But t cannot be equal to 3, right? T cannot be equal to 3 because 3 is not the multiple of 2. 1 and s can be equal to 3 because s is a multiple of 3. So 1 and 3, r can be 3, s can be 3. Then also sum is becoming 6 and this 0. Then also sum is becoming 6 and this is equal to 0. 1, 3 and 2. One case which we are forgetting is, sir, r is 1, s is 3 and t is 2. 3 plus 2 plus 1 is also 6. Na? So, this is a specific case that also we'll have to write. R is 1, s is 3 and t is 2. Now, apart from this, I don't think any other case can be formed, right? Where s is a multiple of 3, t is a multiple of 2 and r plus s plus t is equal to 6. So, these can be the coefficients of rational term. That's it. These can be the rational, these r, s, t only will form our rational terms. So, now finding the terms. Now, we'll find the terms. We'll be finding the terms, na? So, for 0, 0, 6, for example, let's say 0 factorial. R is 0, S is 0, only T is 6. 6 factorial by 6 factorial. Multiplied with 1 to the power 0, 2 to the power 0, T to the power 6 by 2. Why have I written T over here? 3 to the power T by 2. 3 to the power T by 2. 3 to the power 6 by 2, that means 3 to the power 3. So, this multiplied with 3 to the power 3. That's it. Plus, this will be one rational term. Another rational term 600. So 6 factorial divided by 6 factorial because both other will be 0. So 6 factorial 1 to the power 6, right, into 1. 1 to the power 6, 2 to the power 0, 3 to the power 0 plus 6 factorial divided by, third case 0, 6, 0. This will also come out to be same only. 6 factorial divided by 6 factorial multiplied with 2 to the power 6 by 3. Wait. In second case, in first case, so correct. In second case, in third case, 2 to the power 6 by 3. That means 2 to the power 2. Sir, can you explain this type once again, sir? I missed the first half of the question. Heisenberg, from where, bache? Jaldi, tell me. Beta, this is multinomial theorem basically. This question came in 2025, this year only. Before this question came in 21. Before that, this question in 22, 23 and 24, multinomial question we didn't see. I think 21 or 20 this question came, that was I was telling. But this question, students tried to solve it with general expansion of two terms. Took these as two terms, took these as two terms. So, that is not a convenient method. Better method and suggested method would be that solve it like a like multinomial theorem only. What is your multinomial theorem? Multinomial theorem is this. X plus y plus z to the power of n will be equal to n factorial divided by r factorial, s factorial, t factorial multiplied with x to the power r, y to the power s, t to the power z. This is simple theorem. Okay, where r plus s plus t will always be equal to n. In this expansion, r plus s plus t will always be equal to n, and summation, obviously, summation of all. Summation of these and a summation of these. Here there will be a summation. I forgot to put summation. Alright, summation of these. Now this is what I was telling. So this particular expansion will become 6 factorial, r factorial, s factorial, and like this. And now what am I saying? That for two conditions we have to satisfy, that r plus s plus t should be equal to 6 and r plus s plus t should be equal to 6, and we want rational terms. So, s should be a multiple of 3 and t should be a multiple of 2. So, only these cases are formed. 0, 0, 6, 6, 0, 0, 0, 6, 0, 2, 0, 4. Why? Because 2, 0, 4, because s cannot be a multiple of 2. Right? So, 2, 0, 4, 3, 3, 0, 1, 3, 2. These cases we formed. Now, we were on the third case. Third case where 6 factorial by 6 factorial multiplied with s 2 to the power s by 3, that means 2 to the power 2. 2 to the power 2 plus 6 factorial. All cases we have to just write like that. 6 factorial divided by 2 factorial into 4 factorial, 2 factorial into 4 factorial multiplied with 1 to the power 2, that is 1 only, and 3 to the power 4 by 2, that means 3 square. Correct? Plus, this case, 6 factorial divided by 4 factorial into 2 factorial multiplied with 2 to the power 1 to the power 4 and 3 to the power 2 by 2, that means 3. Right? Then 330. So 6 factorial divided by 3 factorial into 3 factorial multiplied with 1 to the power 3 and 2 to the power 1. So multiplied with 2. That's it. 132, that means 6 factorial divided by 1 factorial, 3 factorial and 2 factorial. So 3 factorial multiplied with 2 factorial multiplied with 1 to the power 1, no problem. 2 to the power 3 by 3, that means 2, and 3 to the power 2 by 2, that means 3. So this will be your answer. And these will be easily solved. All of these, 120, this is 27, this is 1, this is 4, this will also, all these will be solved, and total of these will be your answer. Right? This is how you are supposed to solve if a question comes on multinomial theorem. If you see three terms, then solve it like this only, please guys. Okay. Other approach, there are other approaches, longer approaches are there. That is why multinomial theorem is introduced, so that we can solve the questions based on these only. Okay, any doubt, anything else? Heisenberg clear? All good? Chaliye, let's move ahead. Next question. Good question. This again is a good question based on, see, I told you in the starting, binomial coefficient series, summation of coefficients is going to be helpful everywhere. Have complete, rectification of all the formulas, the coefficient formulas only of binomial theorem. I would suggest that. That will really help you to solve the questions in time, otherwise you'll take time. Alright, try to solve this, give it a try. Can you tell me the answer? If you have solved this once, no, you can tell me the answer. Okay. Now, pay attention over here. Summation of, now first let me show you the formulas once again. Okay, so that you won't say, sir, you're randomly applying things. R is n to the power 2, n multiplied with 2 to the power n minus 1. This formula I think will be used over there. Right, this formula I think is going to be used over there. Now see, let's see. Summation of R equal to 1 to 30 R square 30 CR whole square divided by 30 CR minus 1. Now it feels like, but we cannot split. No, NCR whole square is 2NCN, that we know. Summation of NCR whole square is 2NCN, that is also a formula. But how will we split like that? We cannot split like that. What can we split over here? We know that NCR divided by NCR minus 1 will be N minus R plus 1 divided by R. This is very applicable, mostly used. Okay. Now, so what we can do is summation of R equal to, I am not writing 1 to 30 right now. Okay. So R square multiplied with, I will break like this, 30 CR divided by 30 CR minus 1, because I can see that formula being used, and I'll multiply this 30 CR square, no? So I'll write like this. Now this thing over here, this, my dear students, this thing will become what? 30 minus R plus 1 divided by R, right? So this just became 31 minus R divided by R. Okay, this just became 31 minus R divided by R. Which color was it here? I forgot the color. Okay, leave it. Okay, this color it was. Okay, now R square. So this will become R square multiplied with 31 minus R divided by R. Now I have 1 R, I can cancel this, but still I want to get rid of this R square completely, then only I can expand this summation. So now this another 30 CR. I know NCR can be written as N by R, N minus 1 CR minus 1. This I should know, right? NCR can always be written like this. N by R multiplied with N minus 1 CR minus 1. Here is a multiplication. So this I can write like this, 30 by R multiplied with 29CR minus 1. What will happen? This R will cancel this R square now. This is what is going to be helpful. This is what is going to help me. So now 30 minus R multiplied with 30 into 29CR minus 1. Okay. So R equal to 1 to, okay, let's not write like this. Right. So 31 minus R multiplied with 30 multiplied with 29CR minus 1. R is moving from 1 to 30. Alright. This is what we are supposed to find. Now 30 will come out of the summation. No problem. Right. Now what we can do, R equal to 1 to 30, 31 into 29 CR minus 1, right, minus, now this so we can split now, minus summation of R 29 CR minus 1. This is our, we are going to do it. 1 to 30 summation is going from. Here also 31 will come out, 31 into 30 summation of R equal to 1 to 30, and this is 29 CR minus 1. Summation of NCR. Summation of NCR is 2 to the power n, right? Summation of NCR, R equal to 1 to n, is given by 2 to the power n, right? Simple, 2 to the power n, very simple. Derivation is also there for this. You can remember this formula, right? Now 29C0, 29C1, 29C2, 29C3. This is what? 29C0, 29C plus 29C1 plus 29C2 plus 29C3 till 29C29. So this is 2 to the power 29, right? This is simply my 2 to the power 29. Here what will I do? Here what will I do? Here I have R, I can apply R NCR, which is 2 to the power, which is n into 2 to the power n minus 1. Right, this formula which I told you, R NCR is n into 2 to the power n minus 1. R NCR summation from R 1 to n. But here R into NCR. Problem is that we don't have same thing over here, right? We don't have R and R. So we'll do that. We'll create that. No problem. What we can do, this thing only will write like this. This thing will write like this, summation of R plus 1 minus 1, right, or summation of R minus 1 plus 1. Let's do like this, right? R minus 1 plus 1, same thing only, 29 CR minus 1. This will become what? Summation of R minus 1, 29 CR minus 1 plus summation of 29 CR, right? This is how it will become. I'll write here also once again. So this will become summation 1 to 30 R minus 1 29 CR minus 1 plus summation 1 to 30 29 CR minus 1, right? Now this has become an easy problem. So 31 into 30 multiplied with, this is what, 2 to the power 29 minus R NCR now. So 2 to the power, sorry, n into 2 to the power n minus 1, right? So it will be, what is our n? 29 into 2 to the power 28. N is 29. N into 2 to the power n minus 1 will become the formula, plus this is what? This is again 2 to the power 29. This is again 2 to the power 29. This, from this whole thing, what was the question? Alpha into 2 to the power 29. Right, alpha into 2 to the power 29. So from this whole thing, we'll take first 2 to the power, acha, here was 28. This was 28. N into 2 to the power n minus 1. 29 minus 1 will be 28. Right, 2 to the power 28 will take common from all of these. So we'll get 31 into 30 into 2 minus 29 plus 1 plus 2. This is what we are getting. Right, so one more 2 will come out. 31 into 30 into 2, 60 into 31. This will be a long calculation, I think. Just do the, oh my god, just do the calculation once. Not long calculation also. 600 into 31, 31 into 6, 196, 19600 minus 22 plus minus 29 plus 2. So, but we need 2 to the power 29, na? So we'll have to create one 2 to the power 29. This 2 will take out the 29 plus 2, 27, minus 29 plus 2 minus 27. Okay, let me write 2 to the power 28 multiplied with 31 into 30 into 2 minus 27. 3 also we can take out common. But how will 2 come? Two should come out common here. Why is 2 not coming out common from here? I hope we didn't make any 2 to the power n. Okay, this is correct. This is also nc n 2 to n into 2 to the power n minus 1. This is also correct. Wait. This will be minus 2, right? Minus was multiplied over, minus was over here and we split this. So this will be minus 2, sorry. This will be minus 2. This will be minus 2. This will be minus 2 over here. So this thing becomes minus 31 it will become, no? So 31 will remain out. 31 into, so this will become 30 into 2 minus 1. 60 minus 150. This is how it is going to become. Now you can create 2 to the power 29. Now you will be easily able to create 2 to the power 29. Okay. Tell me what will be the answer. Come on. So this you can write it as 50. This over here you can write it as 15 into 2, 131. One of the 31 we are taking out. This minus this minus this minus this minus this. Okay. Minus 31. So this will become 15 into 31 into 2 to the power 29. 15 multiplied with 31 multiplied with 2 to the power 29. We are getting 29, 30 into 15, no? So this is what it is going to become now. And our answer will be, alpha will be equal to, here alpha will come out equal to 30 into 15. 30 into 50, 31 into 15, sorry, 31 into 15. It will become 31, na? 31 into 15. We are going to get 31 multiplied with 15 as the value of alpha directly. So you see, formulas, binomial coefficient formulas in the properties are going to be used a lot. A lot of times they are going to be used. This question again, I think this year's question only. This type but has appeared a lot of times. They'll give you a complex looking expression with high powers. You know, this time in this question the power is not that high, but they might give you high powers also. But the catch is very simple. When you expand x plus y to the power n and x minus y to the power n, terms get cancelled, right? You can try expanding over here if you want. So when we expand, suppose x plus y to the power n plus y, x minus y to the power n. If you observe, this will be nc0 x to the power n y, y won't be there, plus nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2 y square, right? This will go like this, plus this thing. This thing is what? NC0 x to the power n minus NC1 x to the power n minus 1 y plus NC2 x to the power n minus 2 y square, right? So now what will happen? These terms which are odd have started cancelling themselves. The terms which are odd have started cancelling themselves. All the odd terms will get cancelled. Plus and minus, plus and minus. NC3 will cancel with NC3 over here. So this will just become 2 times of NC0 x to the power n plus NC2 x to the power n minus 2 y square, and like this. This will keep going on like this. 2 times of this. Okay. This, if you know, then you can solve this variety of question also very easily. Right? If we expand this thing, let's say we expand this thing, what do we get? Try expanding once on your own. Okay. Try expanding once on your own. 5c0, right? X to the power 5 and this root thing to the power 0 plus 5c1 x to the power x to the power 4 and this root thing to the power of 1, right? Plus 5c2 x to the power 3, this root thing to the power 2, right? This will go like this, plus brackets, right? 5c0 x to the power 5 minus 5c1 x to the power 4 and this root thing to the power of 1, right? Minus will come, no? This will be expanded like this. Minus is there. So minus 1 to the power 1 will give us minus only, right? Minus thing to the power odd power will give us minus only. Plus will come here, 5c2 x to the power of 3 and this root thing to the power of 2, correct? It will keep going on like this and till 5 it will go, right? So which terms are remaining over here and which terms are cancelling? These odd terms are cancelling, right? So odd terms are cancelling, that means this entire thing, only even terms will remain. So 2 times of even terms. Even terms means NC0 x to the power 5 will come 2 times. Okay. NC0 x to the power 5, let's write it as x to the power 5 only, plus NC2 will come, right? NC2 will come. What will be NC2? X to the power 5C2, sorry, 5C2 x to the power of 3 and this root to the power of 2. Root to the power of 2, can I write it as x cube minus 1 only? Root to the power, root square, right? So, and which term will come? 5c4 will come, sir. 5c4 will also come. X to the power 1 will be there, but this root thing to the power 2, that means x cube minus 1 whole square will become. This root thing will have power 4, right? X to the power will be 1, but the root thing will have power 4. So, x cube minus 1 will be squared, and this is what we are going to have. Now, we can do the question very simply by just comparing the coefficients. So, this is 2 multiplied with x to the power 5 plus 10 x cube multiplied with x cube minus 1 plus 1. 5c4 will also 5c1. So, this is 5 only, right? 5x multiplied with x cube minus 1 whole square. So, x to the power 6 plus 1 minus 2x cube. Just expand and compare the coefficients you have. You'll simply get, right? So, 2 multiplied with x to the power 5 plus 10 x to the power 6 minus 10 x cube, correct? Plus 5 x to the power 7 plus 5x minus 10 x to the power 4. This is what we are going to have, right? So, coefficient of x to the power 7, x to the power 5, x to the power 3 and x. Coefficient of x to the power 7, x to the power 5, x to the power 3 and x. This is your alpha, this is beta, this is gamma, this is delta. Right? Alpha will become what? X to the power 7 coefficient. X to the power 7 coefficient will be 10. 5 into this 2, 10. Right? Coefficient of x to the power 5. Where is x to the power 5? This will be equal to 2. Coefficient of x to the power 3 will be minus 20. Right? 2 into 10. Coefficient of x. Where is x? 10. This will also be equal to 10. Okay, you have all the coefficients now. you can just put alpha, beta. Now these two linear equations you will have to solve. That's it. These two simple linear equations you are supposed to be solving. Right, put alpha over here, no? Put alpha u beta v. So 10u plus 2v is equal to 18. Right, simply gamma u delta v. So minus 20u plus 10v is equal to 20. Solve these two equations. U plus v only you have to tell. So multiply the upper one by 2. So this will become 20u plus 4v is equal to 36. So we'll get 14v is equal to 56. V will come out as 4. Right, V will come out as 4 and U will come out as 1 then. 4 2s are 8. U will come out as 1. 4 plus 1, 5 will come as your answer. 5 will become your answer. Okay. So this is one variety of question which is repeating. Now remainder problems. You can expect one remainder problem every time. How to solve them? We should be very quick and we have to be very quick, as well as I should say that easily and confident on solving these problems, because these repeat every year. One problem will be there almost in every set. Almost, I'm saying almost in every set you'll get to see one of this type for sure. One problem of this type will definitely be there. So 7 to the power 103 is divided. Achha, here one important thing you can note down. This is called Fermat-Little theorem. The theorem is very simple. If problem comes on that, two things you should know, right? A to the power m minus b to the power m is always divisible by a minus b, right? It's not necessary it will be used over here, but few properties I want to tell over here which you should remember before the exam. A to the power m minus b to the power m is always divisible by a minus b, right? Similarly, a to the power n plus b to the power n is divisible by a plus b if n is odd. Only if n is odd, then a to the power n plus b to the power n will be divisible by a plus b if n is odd, right? Third thing which you should know is a to the power p, right, divided by p will be equal to a if p is a prime number. Very important and handy these things can be. A to the power p, when we divide it by p only, then then your remainder will be a. Then your answer will be equal to a. Okay. So, all right. Let's solve this question now. Now, apart from this, these are direct tricks. Apart from this, if this type of question comes, how to solve? Now, try to create a 23 or a multiple of 23 over here. Try to create 23 or a multiple of 23 and try to break. But 103 is a prime number. 103 is definitely a prime number. So first I'll break this prime number so that I can factorize 103. So I'll write it as 7 into 7 to the power 102. Right? 7 into 7 to the power 102. Now I can break this power and the base in terms of 23 or some number which is nearby 23. Right? Now, how can I do that? 7 to the power 102 I have. Now 23, which multiple of 23 will be nearby some power of 7? For example, 23 into 2 is 46, but 46 is 5 away from 49. Try to create 1 less or maximum 2 less. Right? 1 less or maximum 2 less, or 1 more or maximum 2 more, like that. I'll explain you with the example. For example, over here, if we see 23 multiplied with 11 is 253. And 7 to the power 2 is 49. 7 to the power 3 is 49 into 7, that is 343. So 49 is far from 46. So 46, 23 into 2 will be 46, but 49 is 3 away. Then again we'll have to calculate at 3. So let's move at more powers of 7. Try to reach near 343. try to reach near 343. How can we reach near 343? Think. Just think in your mind. Try to reach near 343. But 23 multiplied with 15. Let's check 23 multiplied with 15. 15, 10 plus 3, 13. And this will become 2. So 5, 4 and this will become 345. 23 into 15 is 345. 23 into 15 is 345. And 343 and 345, chalo, let's work with that only. Not a problem. 7 multiplied with 345 minus 2. Because 7 to the, bhai, we can write like this, no? 7 multiplied with 7 to the power 3 multiplied with 3 are 9, 40, 3 3s are 9, 1 2 3, 34. Correct, no? 9, 1 2 3 4 are 12. 34 into 3 is 102. Right? 7 to the power 3. Now this 7 to the power 3 also I am breaking in terms of multiple of 23. So 345. This is 343. Right? So 345 minus 2 to the power 34. I'll try to write it like this. Now 345 is a multiple of 23. So 345 is divisible by 23. Then many of the terms of this expansion will be divisible by 23. So 7 multiplied with 340, for example over here, 334C0, right, 345 plus minus 34C1, 345 to the power 33, right, and 2 to the power 1, minus we have already taken out, plus 34C2, 345 to the power of 32, 2 to the power of 2. It will keep going on like this, right? Last term will be what? Last term will be 34C34, 345 to the power 0 and 2 to the power 34 will be there. 2 to the power of 34 will be there. Now if you pay attention, in this the entire, all these terms are divisible by 345. That means divisible by 23 also. If a number is divisible by 14, it is divisible by 7, definitely. If a number is divisible by 21, it is also divisible by 7. If a number is divisible by multiple of a number, it is divisible by that number, right? So, if it is divisible by 345, all of these are divisible by 21. These are divisible by 23, not 21. Okay, all these are divisible by 23. 7 into these, again, right? Not a problem. What will not be, remainder will come out what? What will be the remainder from here? Remainder will come out as last term, which will be multiplied with this 7. 7 multiplied with 2 to the power 34 will be our remainder right now. But remainder cannot be this big. Remainder cannot be this big. Right? We'll break again. We'll try to break it again. Now we'll check. Now we'll check with 7 multiplied with 2 to the power 34. So 2 to the power 34, not anywhere near, right? But 23 multiplied with 10, which is 230. 23 multiplied with 11, we saw. 23 multiplied with 11 is 253. And 256 somewhere will be near. 256 we can create, right? 256 we can create over here. Or what else can we create? 2 to the 8, 16, 32. But 23 multiplied with 2 is 46. And 46 is not coming anywhere near the power of 2's. But 256 will be there. 2 to the power 6 is 64. 7 is 128. And 8, 2 to the power 8 is this thing, 256. But 2 to the power 8 cannot be created over here. Right? Why? Because 34 is not the multiple of 8. Right? So what we'll do, 7 multiplied with 2 to the power 8, we'll break it like this. 7 multiplied with 2 to the power 4, 2 to the power 2 multiplied with 2 to the power 34. Right? Now this will become 7 4s are 28 multiplied with, this will be 32, right? 32. So 2 to the power 32. Now we can write at 2 to the power 8 to the whole power of 4. Correct? Now 28 multiplied with 2 to the power is 256. 256 or we can write 253. We want to use 23 multiple, 253 plus 3 to the power 4. Right. Now this 28, this expansion also 4C0, 4C1, 4C2 and 4C3 will be divisible by 253. So they will be divisible by 23 also. Right. Only 4C4, 3 to the power of 4. This will not be divisible. Getting my point? Only 4C4, this 3 to the power of 4 will not be divisible. So we are getting 28 multiplied with 81. Now 28 multiplied with 81, we can check very easily. Dinesh Ram says done. 28 multiplied with 81. How to now finding the remainder? 28 write in terms of 23. 23 plus 5 multiplied with 81. 23 next multiple is 46 and third multiple is 69. So 69 plus how much it will come? 12. Correct? 12 only, na? 12. Now see, this will become what? 23 multiplied with 69 plus 23 multiplied with 12 plus 69 into 5, right? Plus 12 into 5. All these are divisible by 23. This is divisible by 23. This is divisible by 23. This is divisible by 23. Only 60 is not divisible by 23. So we'll check the remainder over here. 23 into 2, 46. 46 plus 14 will be 60. So 14 will be our remainder. Remainder will come out as 14. But you are not supposed to solve it this slow. You have to be faster at calculation. So practice these questions. This is one question which I solved, which I showed you how to solve. But practice these questions so that you can be quick at this. Some will be easy. Some direct tricks that I told you in the starting of this question. Direct tricks, sometimes direct tricks will be applicable. I'll show you those type of questions also where direct tricks. Direct tricks means not parabola wala direct tricks. But I mean tricks can be used. Okay. Come on, tell me the answer for this one. Divided by 21. Divide by 21. Now check the multiple of 21 which is near to 428 or some power of 428. Power of 428 will be, I think, complex. Come on, can somebody give me the answer for this one? You can also factorize 428 and then try to do it. Not a problem. Right? Or check the multiple of 428 near 21. So 21 into 10, 21 into 20, let's do. 21 into 20 will be our 420. And a 420 plus 8 we can do, I think. And a 420 plus 8, we can start with 420 plus 8. So 420 plus 8. 420 plus 8 to the power 2024. This will be divisible by 21. What will be the remainder? From here, remainder will come as remainder last digit only, right? Last digit only. 8 to the power 2024 will come as your remainder. And 8 to the power 2024, correct? Check once. Any problem? Now, some power of 8 which is near the multiple of 21. Which power? 8 2s are 64. 21 into 3 will be 63. Very good. Nice. So this we'll write as 8 square which is 64. So 8. Now we'll write this as 8 square which is 64. So 8 to the power 2 to the power of 1012. This will become. Right. And this will become our 64 to the power of 1012. And 64 can be written in terms of multiple of 21 which is 63 plus 1 to the power of 1012. Correct ji? Right. 63 is a multiple of 21. 3 to the 6. Right. So this is now from here what will be our remainder? From here what will be our remainder? 1 to the power of 1012 will be our remainder. That means 1 only. So simply solved. Right. Last digit. Only last term will be your remainder ji. Last term will be your remainder. So answer of this will be just 1. Very simple. All these questions have been asked in JEE. This should be your speed. You cannot expand and keep checking. You should know last term will be the remainder, last term will be the remainder, last term will be the remainder. This is how you are supposed to be solving. This question again, this year or last year, I think, not sure. Yeah, but generally what they ask you, number of integral terms or sum of integral terms, something like that. This time what they asked, least value of, try to look at the question, least value of n for which the number of integral terms in this binomial expansion is 183. This was different. This type of question, once same type has come, I think 23, the same type of question came, right? This variety of question they asked in 2023. What they are saying is, what should be the least value of n for which the expansion will have integral terms equal to 183. Now, generally, how do you find integral term? You'll say that expansion of this will be NCR 7 to the power of n minus r by 3 and 11 to the power of n by 12. R by 12, sorry, r by 12. Right? This will be the expansion. And then you will simply say that r should be a multiple of 12 and r should be a multiple of 12 and 3. You will find the LCM of 3 and 12, which will be 12, and all the multiples of 12 you will find. If you want to find the sum, if it is a small expansion, you can find the sum also, or otherwise number of terms, you can simply find how many multiples of 12 are there for r between 0 to n, if n was given to you. But here they are asking what should be the least value of n, so that the number of integral terms is equal to 183. How to approach this type of question? Now it is saying that number of integral terms should be equal to 183. Achha, for integral terms, this n minus r by 3, if you pay attention at this thing, this complete n minus r by 3 should be integer. Correct? If we want integral terms, can r by we cannot say no 3 is just the multiple of, in this case we cannot say 3 is the multiple of r, 3 is dividing r and 12 is also dividing r. We cannot only focus on r this time, we have to take care of n also. So n also has to be a multiple of 3, and if n is a multiple of 12, then it will always be a multiple of 3. This only was the catch in this question. Otherwise what? How many r's? R should be there. If it's the question itself is saying number of integral terms is 183. That means the total values of r will be equal to 183. There will be total 183 values of r. And r, for it to be integral, for the term to be integral, r can be a multiple of 3 and 12 both. That means a multiple of 12. LCM of 3 and 12 is 12. So that means it should be a multiple of 12. Getting my point? It should be a multiple of 12. Multiples of 12 till and 183 multiples of 12. Now, small catch over here, 183 multiples of 12 or 182 multiple of 12, because every time when we check the integral terms, if you have solved these type of questions, we know we have to check for NC0 also, right? Because first term in this expansion, first term will be what? First term will be NC0, right? And this 7 to the power of n by 3. This will be your first term. And we are already saying that n minus 3 by 3 will be an integer. Why? Because n will be a multiple of 3. We can simply say n is a multiple of 3 from this, because we know that this entire exponent has to be an integer. Then only this term can become integer. So first term will be an integer. It will be integer. This first term. Why? Because first term is there. Now after this, all the 182 multiples of 12 will give you the rational terms, will give you the integer terms. All the 182 multiples of 12 will give you the integer terms, and that will be the minimum value of n. Least value of n. After that, more can be there, but minimum this should be there. At least 182 multiples of 12 should be there for 183 integral terms in this particular expansion. So 12 multiplied with 182, how much? 2184, I think. Check once again. Very important, very conceptual question. This is very solution is not very big. Solution is very simple only. You have to understand that first term will also be integer, right? So 182 multiples. Many students will reach till here. 12 multiplied with 183 they will do, right? Because they'll simply understand it's R should be a multiple of 12 and there will be 183 multiples of 12. But 183 is also wrong. 12 should be multiplied with 182 because first term will definitely be an integer. If R is a multiple of 12, then this n minus R by 3 will be integer and n will be a multiple of 3. That means this will be an integer term. Let's go ahead. This question, very tricky kind of question. This question is repeated 3-4 times. This same time, generally what they do, generally they'll give you a question like this, right? R equal to 0 to 11 and 11C 2R plus 1 divided by 2R plus 2. If this was the question, no? If this was the question, then we can give the answer simply, very easily. 2 to the power 12 minus 1 by 12. This will be the answer. Why? Sir, how? Because one formula I showed you in the starting, R equal to 0 to n for NCR upon R plus 1 will always give you 2 to the power n plus 1 minus 1 divided by n plus 1. This formula can be used. So generally this has come, right? In 5 times, I think 2 times or 3 times this only came, where the summation was from 0 to 11. But recently they changed this summation because they knew that trick will work. This direct formula, students remember. NCR upon R plus 1 summation from 0 to n will be equal to 2 to the power n plus 1 minus 1 divided by n plus 1. This summation most of the students do know. Most of the students do know this. If you don't know, then also write this. If direct question, summation is from 0 to n, this and this are same, then the answer will be 2 to the power n plus 1, 12 minus 1 divided by n plus 1. Direct answer will come. And a 25 ka question only this is kya, Pradeep Jain? 2035. M minus 1. Okay. Okay. Now, right, so direct formula we know, but in this case something else is happening. In this case something else is happening. How, Pradeep Jain? 2035, how is that the answer? That's what I am saying. No, here 0 to 5 is the summation, right? Constraint is different. So this will have to solve a little bit differently. By integrating, yes. By integrating, if you solve, that will make it very complex. I told you over here. Here I told that when I showed you this formula, when I showed you this formula, I told you that this is derived by integration. So yes, you can do by integration in 1 plus x to the power n, right? Integrate it and put limit from 0 to 1 and again integrate it by putting limit from minus 1 to 0, right? Then add both of them, you will get the answer. You will get this summation only. But actually in this question, we don't have to do that much. I'll tell you one more approach for this, right? Because integrating will make it very long and complex. 1 plus x to the power n. 1 plus x to the power n. You can integrate and expand and integrate on both the sides by putting limit from 0 to 1 and minus 1 to 0, right? I think it will come. But here we can do something else also. Pay attention. Okay. What we can do is R equal to, leave summation. Pay attention at this part first. Right. 2R plus 1 divided by 2R plus 2. And this particular trick, mark my words, works every time. This particular trick will work every time. Many times it will work. Right. What am I going to do? I'll expand it. I'll open it. So this will be 11 factorial divided by 2R. 11 minus 2, let me be a bit neater, 11C 2R plus 1 divided by 2R plus 2, right? Let's expand it. So this will become 11 factorial divided by 11 minus 2R plus 1, that means 10 minus 2R factorial, okay ji? And multiplied with 2R plus 1 factorial, right? And multiplied with 2R plus 2 factorial also, no? This will also divide, or let's divide 2r. Let me write a couple of more steps so that you are confident with this particular, not factorial, 2r plus 2 only. Okay. Now this 2r plus 2 will get multiplied with 2r plus 1 factorial. 2r plus 2 multiplied with 2r plus 1 factorial. We take 1 minus x and then limit 0 to 1 and add, then answer will come. Yes. 2r plus 1 factorial, 2r plus 2 factorial. So it, bhai, 11 into 12, 12 into 11 factorial is 12 factorial only, na? So this 2r plus 2 2r plus 2 multiplied with 2r plus 1 will become 2r plus 2 factorial only. So this is nothing but 11 factorial divided by 10 minus 2r factorial multiplied with this this will make it 2r plus 2 factorial. Now, whenever this type of situation arises, listen to me. Whenever this type of situation arises, check this. Check the sum. 10 minus 2r plus 2r plus 2. What is the sum? Constant sum comes. 12 is the sum. So always try to convert into NCR again. You can again convert it into NCR just by multiplying 12 over here and dividing by 12. So this will become 1 by 12. 12 into 11 factorial will become 12 factorial divided by 10 minus 2r factorial and 2r plus 2 factorial. Now what is this? This is nothing but 1 by 12 multiplied with 12c 2r plus 2. Check. Correct? 12 minus 2r plus 2 will be again 10 minus 2r. This is nothing but this. Getting my point? This only is important over here. If you follow this, then now you can solve it very easily. Now you will be able to solve it very easily. Why? Why am I saying you will be able to solve it very easily? Summation of r equal to 0 to 5. Correct? This is what 12. What did we solve it as? And 1 by 12 will take out common. 12c 2r plus 2. Right? So this is 1 by 12 common again. Summation from 0 to 5. Now summation. Check the summation. What will be the first term? Okay, let's open the summation. Let's open the summation. Right? What will be the first term? 12c 2 plus 12c, put 1, 12c 4 plus 12c 4 plus 12c 6 plus 12c 8 plus 12c 10 plus 12c 12. Right? This only will come. Sum of binomial coefficients. Correct? Now, if you remember the derivation of these, 1 plus x to the power n, which is nc0 plus nc1 plus nc2 plus nc3, and it keeps going on till ncn, and then 1 minus x to the power n will become nc0 minus nc1 plus nc2 minus nc3 dot minus 1 to the power n ncn. This is the expansion. If we add both of them, when we, and if we put this is what? This is equal to 2 to the power n and this is equal to 0. Why? How do we get it? By putting x equal to 1. In both the cases, if you put x equal to 1, this side will come 2 to the power n, this side will come 0. In all these, x is already equal to 1. I have already put x equal to 1. Now, when you add both of them, you get 2 to the power n equal to 2 times of nc0 plus nc2 plus nc4 plus nc6, because these will get cancelled. Okay, till ncn, if it is even, right, it will be even only, right, ncn, till ncn you'll get, right. So now 2 to the power n by 2 is your sum of even coefficients, right. Even coefficients is the sum, and the sum of odd coefficients, if you want to do, subtract them, right, subtract them, then also 2 to the power n will come. Okay, so this is the case. Now this is what we are going to use over here. Now here, what do we not have? 12c 0 we don't have, right? We don't have 12c 0. So we'll add and subtract that, right? We'll add and subtract. So this will become 12c 0 will add, right? 12c 2 till 12c 12 minus 12c 0 again, right? Add and subtract. So this will become what? 1 by 12 multiplied with this sum. This sum will be what? N 2 to the power n, that means 2 to the power 12 divided by 2, right? Minus this, minus 1. This will become your answer. 2 to the power 12 will be what? 2048 into, 2 to the power 11 only, no, it will be 1024 into 2, 2048 minus 1, 2047 divided by 12. 2047 divided by 12 we are getting, 2047 divided by 12. So 2047 minus 12 will be 2035. 2035 was the correct answer, which I think Pradeep Jain solved. 2 to the power 11, correct. But see, this was better approach. No, integrate this, all these things will come in your mind directly. If you have solved a couple of questions, no, these things will come in your mind directly. Integrating and doing it, that's derivation, right? That is the derivation of the formula which I showed you, which is 2 to the power n plus 1 minus 1 divided by n plus 1. That is the derivation of that formula. Sir, इसके लिए भी कभी कभार क्लास ले लिया करो प्लीज. ठीक है, चलो ली है बेटा. All these things are taught already. I've taught these things in the classes. Why are you saying I haven't? Don't break my heart, boy. Success is everything. Hi beta, how are you? I have taken classes for these things. If you didn't watch that, then what can I do? Binomial theorem classes in RRR also I showed you this thing, and in the earlier class also. Okay. Constant term in the expansion of. So constant term, whatever is the power of x, make it equal to 0. That will be the constant term, right? So constant term in the expansion, write the general term. General term from this will be 12cr, right? 12cr, fifth root of 3 to the power by x, writing simply only 12 minus r multiplied with 2x divided by cube root of 5 to the power of r. Now take out x from here. Take out x. What will be the power of x? So x to the power will be minus 12 minus, this is x only, na? 12 minus r. Minus 12 minus r, right? X is in denominator, and from here x to the power will be r. Correct? From here x to the power will be r. We want to make the constant term. Constant term means independent of x. There should not be x. When will x not be there? When x to the power is 0. From here what are we getting? The powers of x. X powers are coming out to be minus 12 minus 2r. This should be equal to 0. This should be here something. Minus if we will multiply, wait. Minus if we will multiply, x to the power will be minus of 12 minus r. And this will be x to the power r. So this gives us that r minus 12 plus r should be equal to 0. That means 2r should be equal to 12. That means r should be equal to 6. This means when r will be equal to 6, terms will be independent of x. So we just have to take r equal to 6 over here. 12c6 we have to open. 12c6. Now 3 to the power 1 by 5. 12 minus 6, 6. Right? X to the power 6 will come over here, and here, sorry, x to the power minus 6 will come over here, and x to the power 6 will come over here. You can see minus 6 plus 6 becoming 0. Sir, ऐसे ही मतलब Indian Statistical Institute, कहाँ ये सही आ गया यार, पता नहीं बीच में. Okay, right? This will be the term. X will not be there over here. Multiplied with 5 to the power minus 1 by 3. 5 to the power minus 1 by 3. This is 5 to the power 1 by 3. So 5 to the power minus 1 by 3 to the power of r. Acha, 2 is also there, right? 2 is also there. So 2 to the power 6 will also be there, right? Because r is 6, and 5 to the power minus 1 by 3 to the power of 6 will be there. To the power of 6 will be there. So this is given to you equal to alpha into 2 to the power 2 to the power 8 into 3 to the power 1 by 5. So don't solve this. 3 to the power 1 by 5 part you don't have to solve. Now from here you can simply find the alpha. Can you tell me alpha from here? Can somebody tell me alpha from here? 12C6 will be how much? 12C6, calculate 12 into 11 into 10 into 9, 8, 7 divided by 6 into 5 into 4 into 3 into 2. तो ये 6 2s गया, 5 10 2s, 4 8 2s, 3 3 and 2 2 गया. तो ये हो गया 6 12 12 into 11 into 7, 12 into 11 into 7. Two 31 divided by 2 to the power 6 divided by 3 to the power 5. This will become what? This is your 1 by 25. This is what? 1 by 25. Over here we have 25. Right? 3 to the power. This is 1 by 25. And this is coming as 12 into 11 into 7 divided by 25. So 12 into 11 into 7. And 12, 6 to 12, 12 into 7 into 11 divided by 25 multiplied with 3 to the power of 1 by 5 to the power 6 into 2 to the power 6. So 2 to the power 8 we need, and this thing we need. Right? So 25 alpha we need to just tell. Right? We need 2 to the power 8. 2 to the power 8 can be created very simply. Right? From here it will come. 4 is over here. So 4 is over here. So this will become 33 into 7. 33 into 7 divided by 25 multiplied with 3 to the power 1 by 5 to the power of minus 1 by 5 it was na yaar, minus 1 by 5 minus 1 by 5, so minus 1 by 5 minus 6 by 5, so it will become 5 by 6 then. Can be done very easily. It will become 2 to the, so 231 by 25 will come as 2 to the power 8, 3 to the power 1 by 5 and then a 3. 3 to the power 6 by 5 can be written as 1 plus 1 by 5 na. This 6 by 5 can be written as 1 plus 1 by 5. So 3 to the power 1 into 3 to the power 1 by 5. That way if you are breaking it, we are getting this side equal to 2 to the power 8 into 3 to the power 1 by 5 multiplied with 3. And obviously that 231 by 25 will come. This 231 divided by 25 is coming. 231 by 25 is definitely coming. So alpha is becoming what? 231 into 3, that means 693 by 25. Your alpha over here is coming as 693 divided by 25. And what are they asking? Alpha only, right? But your option, acha, 25 alpha they are asking. 25 alpha will become 693. 25 alpha directly will become 693. Thank you. Jalaj. Chaliye. Any doubt, anything, any problem in this question? This type of question, independent of x, find the x power and make the exponent equal to 0. Simple approach. Some things will be there apart from that. Again, the term independent of x is given to you, then find a square. Easy. Try to do this. This you can do on your own. But term independent of x is a favorite question of JEE. This keeps on repeating in JEE. Remember that. Okay, term independent of x. Over here you can simply check the coefficient. 10c r root a x square to the power of 10 minus r. So x square to the power of 10 minus r will come. Right, from here what will come? From here we'll have x to the power minus 3 to the power r. That means 10 minus r minus 3r should be equal to 0. Sorry, 20. Yeah, 2 into 10 minus r. 2 into 10 minus r minus 3r should be equal to 0. So 20 by 2x cube to the power of 4. This term will be equal to 105, and this term definitely will be independent of x. 6 2s are 12, minus 4 3s are 12, right? 12 minus 12, x will go. You don't have to actually write x over here. Without x, it should work. So your type of questions these are. By 0 factorial, that means 0 by 0 factorial. Those things you know, right? So that expansion only we are doing. So 1, this expansion will be 1 plus 2 by 2 factorial plus 3 by 3 factorial plus 4 by, sorry, like this, 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, and it will keep going on like this. This expansion is used in these type of questions, and you have to connect it with these type of expansions. Do we remember these expansions? Anybody? Huh? E to the power x expansion. So now e to the power x minus 1, e to the power x minus 1. Suppose if we put x as 1 over here, so e minus 1 will be equal to what? 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial plus 1 by 5 factorial. This thing is being used over here in this case. This is the expansion that we learn in the limits in the expansion series. Okay. Now pay attention. A is given to you something like this. A is 1 plus 2c2, 3c2, 4c2, 2c2 by 3 factorial, 3c2 by 4 factorial, 4c2 by 5 factorial, and B is somewhat like this. B is a summation is there in the numerator and then denominator. So if in B, if you pay attention, 1c0 plus 1c1 is what? 2 to the power 1. Nahin? This is 2 to the power 2. This is 2 to the power 3. Pay attention. Try to observe this very carefully. Okay. This B, if we observe, this is what? B is equal to what? 1 plus 2 to the power n. That means 2 to the power 1. 1c0 plus 1c1. 2 to the power 1. Expansion of divided by 1 factorial plus. This is 2 to the power 3. 3 terms are there. 2 to the power 2. Sorry. 2 to the power 2. 2 to the power 2 divided by 2 factorial. This is what? 2 to the power 3 divided by 3 factorial. And it keeps going on like this. This is our B. So e to the power 2 factorial, it looks like e to the power 2 factorial. What does it look like? E to the power, sorry, expansion of e to the power 2. Not factor, e to the power 2 expansion. Right? E square expansion will be like this, no? Now at A, if you pay attention, A we have to, I think, calculate. This is your general term. If we look over here, if we look at the general term, so this will be 2 NC2, right? NC2 divided by NC2 divided by n plus 1, right? The general term, n plus 1 factorial. Will this be the general term? Can you confirm? We can write in terms of actually n, instead of n, let's write in terms of r, right? So RC2 divided by r plus 1 factorial, right? 2C2 divided by 2 plus 1 3 factorial, 3C2 divided by 3 plus 1 4 factorial, 4C2 divided by 4 plus 1 5 factorial. This is the general term that we have. 1 plus this series is what we are having. This plus 1, or let me write it like this, 1 plus summation of RC2 divided by r plus 1 factorial, and r is starting from 2, r is starting from 2 to some n, right? It is infinity actually, not even an infinity, right? This is a long series, infinity. Till infinity it will keep going on like this. Correct, Ji? So 2 to infinity RC to R plus 1 factorial. This is this expansion, and B is very simple. B will be able to calculate because this is simply your e to the power 2 minus 1. Correct. Now this you'll have to solve a little bit. This is not RC to R, there is no formula like this for it, right? This you'll have to solve a little bit. Try solving. This we'll have to solve. This thing we'll have to solve. So let's solve over here. R factorial divided by R minus 2 factorial multiplied with R plus multiplied with 2 factorial multiplied with R plus 1 factorial, right? This is what it will become. R plus 1 into R minus 1 into R minus 2, or let's cancel from here. R into R minus 1 into R minus 2. This can be written as R into R minus 1 into R minus 2 factorial. So this will become R into, this will become R multiplied with R minus 1, right? R factorial will become R into R minus 1 into R minus 2 factorial. So R minus 2 factorial will get cancelled. R into R minus 1 will remain, divided by 2 factorial, which is 2 only. So 1 or 2 times of R plus 1 factorial. Right, this is how we can simplify it. R into R minus 1 divided by 2 into R plus 1 factorial. Now again we'll have to break it because we want to cancel this R plus 1 factorial. How can we cancel this? So create R plus 1 over here. We'll have to create an R plus 1 over here. Then only we'll be able to cancel it. No, if we create R plus 1 over here, then only we'll be able to cancel it. Right? Whenever this type of situation comes, we'll try to write it in terms so that we can split the summation. We are still not able to split the summation. Can you see that we are not still able to split the summation? So how can we think of splitting the summation? Whenever this type of situation arrives, try to split the numerator with terms of numerator, with terms of denominator, with the terms of denominator. Here there is a minus R. For example, what I can do is R. What is this numerator becoming? R square minus R. If I have 1 over here, then what I can do? R square minus R. If I create a 1, that means R square minus R plus 2R minus 2R. Let's say plus 2R minus 2R. If I'm doing, so I'm getting R square into R minus 1. Wait. R plus 1 into R minus 2R. R into R minus 1. This, yeah. This R into R minus 1. Can I write it in terms of R plus 1? Suppose if I do R plus 1 into R, it will be R square plus R. I need minus R. So here I'll do minus 2R. Correct. What will happen? The numerator got splitted in terms of denominator only. Correct. So this thing I can write as 1 plus, my A will be 1 plus summation of R plus 1 into R divided by R plus 1 factorial. Correct. Minus summation of, minus 2 times the summation of R divided by R plus 1 factorial. Now why did I do this? Whenever you do this, this expansion will help you. This expansion of e to the power x will always help you. Number and denominator may, if you are getting a factorial, number and factorial in the denominator, then always the use of expansion will come. Right? See over here, R into R plus 1. For example, over here we are getting, this is what? Suppose R is iterating from 2. Where did we put 2 to infinity? Right. Now this is what? R upon 3 factorial. I mean 2 upon 3 factorial plus 3 upon 4 factorial plus 4 upon 5 factorial. It is going like that. So we have splitted it. Yes or no? or you can move from 0 also. You can take from 0 also, not a problem. Just give me a minute, somebody's there. Try to expand it more, try to analyze it more. I'll take 2 minutes. 2 minutes. Okay, give me 2 minutes. I'll just be back. Yes. Probability chapter. Probability, Praveen, actually I'll do with questions, okay? Probability, I'll bring up question series, some 100 questions or 200 questions, where all chapters will try to revise, and probability also I'll cover in that. Don't worry about probability. Probability is small, beta. If you have solved NCERT questions also no properly, probability won't bother you that much. Some PYQs of JEE Mains also, if you solve, that is completed. Okay, PNC should be strong, right? Permutations and combinations should be strong. Sorry, where were we are? I forgot. Okay, so we, what did we do? Okay, till here we reached, right? So this is what 1 plus, now this r plus 1, r upon r plus 1 factorial, r plus 1, r upon r plus 1 factorial. R plus 1 upon r plus 1 factorial will be what? 1 upon r factorial, right? R plus 1 upon r plus 1 factorial. Why? Because r plus 1 factorial I can write as r plus 1 into r factorial. So r plus 1 into r factorial, this will become your 1 divided by r factorial into r. Now r divided by r factorial will be what? R factorial is r into r minus 1. R into r minus 1. So this will be r into r minus 1 factorial. So this will be nothing but 1 by r minus 1 factorial. And this is 1 upon a factorial is very, whenever 1 upon some factorial comes, you should be very happy, right? So here what are we getting? Summation of 1 upon r minus 1 factorial. Okay, moving from 0 to infinity, correct? Minus. Now here is the problem. This is r upon r plus 1 factorial. Here also try to create r 1 upon factorial, right? What we can do? R plus 1 minus 1 we can do. Plus 1 minus 1 we can do. So this will become again 2 times of sigma of r plus 1 divided by r plus 1 factorial minus 2 times of summation of 1 upon, sorry, plus it will become, no, minus is there, so plus it will become 1 upon r plus 1 factorial. Now everything is appearing. This is also what? R plus 1 upon r plus 1 factorial will be 1 upon r factorial. This will be 1 upon r factorial, right? So what do we have? B is coming out to be, A is coming out to be 1 plus summation of, let me take all the terms, 1 upon r minus 1 factorial, 1 upon r minus 1 factorial, okay, minus 2 into summation upon 1 upon r factorial. plus 2 into this became plus because here we split it with a minus, so minus and minus will become plus, right? Plus summation of 1 upon r plus 1 factorial plus 2 times summation of 1 upon r plus 1 factorial. Now pay attention, 0 to infinity, 0 to infinity, 0 to infinity. This you'll be, if you solve 2-3 questions also of these type, no, you'll be able to solve them on your own. Don't worry, very faster here, but understand the explanation very clearly. Now see, what is this? A is equal to 1 plus. What type of series are we getting? If I open this, 1 upon, arey yaar, minus, wait, this should not be r minus 1 factorial, bhai. R minus 1 factorial we cannot create only. But no, oh, sorry, my bad, these limits I have put wrong. These should be from 0. We started from 2. We didn't start from 0, right? We have started from 2. So this is 2 to infinity. Remember? 2 to infinity we are doing. So this is 1 by 1 plus 1 by 2. Put 2 over here, then 1 by 1, put 3. 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial, like this it is going till infinity, right? Minus 2 times of, what is this? 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial. It is going like this, plus 2 times of what? This is what? 1 by 3 factorial plus 1 by 4 factorial plus 1 by 5 factorial till infinity. All these are expansions of e to the power x, e to the power 1 actually. So this will become your 1 plus, this is this first term will become e minus 1 by 2, right? E minus 1 by 2 will be the first term, then minus of e plus 2, and then positive of e minus 2 is coming, and in the end minus 1 by 2, right? Now all these in terms of e. This is what? 1 plus, this is e minus 1, right? This is e minus 1, e minus 1 by 2. Now this will become minus 2 times of, from e we subtracted 1 also, 1 what is e? Expansion of e, 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial, like that. Okay, so this will be 2 to the power of e minus 2 into e minus 2 plus 2 into e minus 2 minus 3, e 1 by 2 and 1 by 2 factorial, so e minus 1 by 2, something like this. In terms of e only you have to break it. One by 2 I am putting because 1 by 2 was there over here, right? 1 by 2 was over here also. 1 plus half the summation of this, no? We took 2 out, remember? Here we were getting some 2, this 2 we had to take out. Here also 1 2 was there. This 2 we had to take out. So that is why e minus 1 by 2 over here. Okay, then e, this will become your minus e plus 2. This thing will become minus e plus 2. This thing is becoming minus e plus 2. This thing is becoming your e minus 1 plus e minus 1, right? No, oh sorry, plus e minus 2, right? Plus e and then minus 2 and then minus 1 by 2 overall. This you have to calculate and this will be your answer for A, right? This will be your answer for A. And B is just e square, right? B I showed you, right? B is just what? B is what here? B is 1 plus 2 upon 1 factorial, 2 square upon 1 factor, 2 square upon 2 factorial, 2 cube upon 3 factorial. So this is nothing but e square. What do you need to calculate? 2b upon a square. Calculate a square. How much is a coming? Calculate all this. Adha, half, e, I think e by 2 it should come. Half is getting cancelled. E by 2 it will come. This will come as e by 2, right? And e square by 4, e square divided by e square by 4. The answer should be 4. Answer will be 4, or if some mistake is there, check once. Acha, 2b square was there, kya? So then 2 will be multiplied here, answer will come 8. Answer will become 8. Okay. So expansions, right? Always use the, many times in binomial theorem you will get to see the expansion of e to the power x, which is x divided by 0 factorial x divided by 0 factorial plus x divided by x to the power 0, sorry, yes, 1 divided, or you start with 1 only. Actually it is like this, easy to remember, x to the power 0 divided by 0 factorial plus x to the power 1 divided by 1 factorial plus x to the power 2 divided by 2 factorial plus x to the power 3 divided by 3 factorial. It's better to remember like this. This becomes 1 plus x square by 2 factorial. Generally in books it is written like this, but expansion, actual expansion is this. So this will come as 1 plus x square by 2 factorial plus x cube by 3 factorial, like this. If you put e to the power 1, then it will be 1 plus 1, 2. 1 plus 1 will become 2. E to the power 1, x is equal to 1. 2 plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial, like this. Very important, this expansion is. Other questions also have come on the basis of this. Suppose this question had some problem, I remember. Next question is, suppose 2 minus p, p and 2 minus alpha and alpha are the coefficients of 4 consecutive terms in the expansion of 1 plus x to the power n, then give the value of this expansion of 1 plus x to the power n, and here 2 minus p, 2 minus alpha and alpha are the 4 consecutive terms. So let's say this is your NCR, this will be NCR plus 1, this will be your NCR plus 2, and this will be NCR plus 3. These are the 4 consecutive terms. I know. These are 4 consecutive terms. So you can apply properties over here, I think. 4 consecutive terms. I think you'll be able to apply property over here, right? If you add both all the terms, suppose if you are the 4 consecutive terms in the expansion of, great. If we are adding all of them, minus p minus alpha plus alpha, answer is coming 4. So it's good. Adding all of them, NCR plus 1 plus NCR plus 2 plus NCR plus 3 is equal to 4. 2 plus 2, 4. Adding all of them, minus p plus p 0, minus alpha plus alpha 0. And this to we know, NCR plus 1 is n plus 1 c r plus 1. So this will become n plus 1 c r plus 1. And this will become n plus 1 c r plus 3. Right? This is one ahead. Right? This formula we know, no? NCR plus NCR plus 1 will be equal to n plus 1 CR plus 1. This formula is also very applicable. Now see, n is same, r is increasing by, wait, some problem is coming. NCR, n plus 1 CR plus 3 it will become, yeah. So, okay, no problem. R plus 3 it will become. This is equal to 4. But I think there is some more problem. How will we be able to solve? PQ and all are not given to us. N is also not given to us. No. No. No, there is some data problem in this question. Some data problem is there in this question, I think. Let me check. Let me check once. Where did I get this question from here? This, how can we solve like this? We don't have anything about P and Q. I'm sure there is some problem with this question. Something I'm not able to find where I found this, but let's try something else. Actually, these two sum is also equal to 2. So NCR plus NCR plus 1 also is equal to 2. So this gives us N plus 1 CR plus 1 equal to 2, right? Similarly, we can get N plus 1 CR plus 3, which is also equal to 2. So we are getting N plus 1 CR plus 1 equal to N plus 1 CR plus 3, but this is also not giving anything. N plus 1 CR plus 1 is equal to N plus 1 CR plus 3. This is what we are getting. But this is also not giving anything substantial. From this, what will we get? Even if we solve this, we'll get something like this. 2 into R plus 1 is equal to N plus 3. This is what we'll get. N plus 1 actually, not 3. N plus 1. N plus 1. When we solve this, no, N plus 1 and N plus 1 factorial will get cancelled, and this is what we are going to get. But this is also not giving us anything. There is no other information. I think there was some problem with this question. There must be some problem with this question, or this is incomplete. Maybe I bought this incomplete. I'm sorry for that. But yeah, if this type of situation arrives, just check what helps you by adding the binomial coefficients. Okay. Chaliye. This is the question I was talking about, right? Remember, this question you'll be able to solve with normal methods also, but if you remember this, this can be easily solved. Summation of NCR upon R plus 1. 11C1 upon 1 plus 1, 11C2 upon 2 plus 1, 11C9 upon 9 plus 1. Right? So, R is moving from, this is what, 2 to the power, this simple answer will be 2 to the power, this is what, summation of 11CR upon R plus 1. From R is increasing from, R is starting from 0, no, R is starting from 1. R is starting from 1. In this case, R is starting from 1, right? But we want to start R from 0. No problem. We'll start from 0. If we open the expansion of R equal to 0, remember this formula starts from 0 to N. Okay. 11CR upon R plus 1 will be what? 11C0 upon 1 plus 11C1 upon 2 plus 11C2 upon 3. It will go till 11C 11 upon 12, right? 11C11 upon 12. It will go till here, right? And last two terms also, last few terms, 11C9 divided by 10 plus 11C10 divided by 11 plus 11C12 cannot happen here. 11C10 divided by 11, 11C12 cannot happen. Right? Till 11C10 it will go. Right? So, R will be from 0 to 10. Or 11C11 can happen. 11C11 divided by 12. This can happen. So, these two terms are extra, and over here this term is extra. This is what is being asked. This is what is being asked. This we know will be equal to 2 to the power n plus 1, that means 12 minus 1 divided by 12. 2 to the power n plus 1 minus 1 divided by n plus 1. This we know will be this. Right? This will know will be this. Is from this thing we subtract 11C0, which is 1 divided by 1, that means 1 we will subtract, What else will subtract? 11c 10 will be 11c 1 only. So 11 divided by 11, again 1. 11c 11 will be again 1 only. So 1 divided by 12 will be equal to 1 by 12. So minus 1 by 12 also. Okay. So this is our answer. That means 2 to the power 12 minus 1 minus 1 minus 2 minus 24 divided by 12. This should be the answer. 2 to the power minus 12, 26 divided by 12. 2 to the power 12 minus 26 divided by 12. So it will be 4070 divided by 12. 4070 divided by 12. And GCD, both should be co-prime, so we'll have to cancel. 2 to the power 12 is 2048, 2048, 40, correct, 4070 by 12, 26, 2035. So I think these two are co-prime, then 2035 plus 6, n plus m will be 2041, then 2041 should be the answer. 2041 should be the answer. 2035 and 6 are co-prime, no, now we cannot cancel them. This will go by 5. It is not going by 3 also. So these two are co-prime and 2041 will be your final answer then. Okay. This is one variety. What is this? Acha, the font is little low, but yeah, this question is good. This question is good. This is saying x plus 3 to the power n minus 1 plus x plus 3 to the power n minus 2 multiplied with x plus 2 plus x plus 3 to the power n minus 3 multiplied with x plus 2 to the power 2, and this goes till x plus 2 to the power n minus 1. The question is saying that let the coefficient of x to the power r in this expression, in this expansion, coefficient of x to the power r is given as alpha r, and the coefficient of x to the power r is given to you as alpha r, and alpha r is given equal to then beta to the power n minus gamma to the power n, where beta and gamma are natural numbers. Then find the value of beta square plus gamma square. That is what is asked. But when we look at it, 2-3 things should come in our mind whenever they are asking about the coefficient of x to the power r, right? Sum of coefficient or coefficient of x to the power r. What do you do is, one technique, one trick which they teach in many, which they have told in many books also, or many teachers also say that put x equal to 1 on both the sides, and then you'll get the coefficients. We won't get the coefficient of x to the power r. We'll get the coefficient of, we'll get the sum of coefficients first of all. And here they are asking about this only. They are saying sum of alpha r, sum of the coefficients from r equal to 0 to n is given to you by beta to the power n minus gamma to the power n. So yeah, this is okay. If you put x equal to 1 on both the sides, you will all, in any identity, if you put x equal to 1 on both the sides, you will always get the sum of coefficients. But how to put, first of all, what is this? This is the expansion of what? Can we write it as this? This can be the expansion of x plus 3 plus x plus 2 to the power n minus 1. Yes or no? This can be the expansion of x plus 3 plus x plus 2 to the power n minus 1, isn't it? One way is this. One way is this, that we put, that we realize this expansion, and this is the expansion of x plus 3 plus x plus 2 to the power n minus 1. And just a minute, okay? Please just give me a second. What is the other observation you are getting? Right. Hanji. So I was saying that you can realize this as the expansion of this and then put x as 1 on both the sides, and then that will give you the sum of coefficients. That's how we do. No, 1 plus x to the power n, sum of coefficients, how do we get? When we put x equal to 1. That's how we get the sum of coefficients. Sorry. That's how we get the sum of coefficients. But in this case, we are not able to realize that efficiently also. What will we do? In fact, because even if we'll take x equal to 1, you see what is happening. 1 plus 1, 2, 2 plus 5, 7 to the power n minus 1 is coming. And 7 to the power n minus 1 will come. And this side, what are we going to get? 4 to the power n minus 1 plus, this is not visible, only 4 to the power n minus 2 into 3. Something like this we'll get, and then we'll have to take 4 to the power n minus 1 or something common and then realize it as the summation, right? But one more approach can be there for these type of questions. But if you realize these type of expansions, if you simply observe these type of expansions, what are these? These are GPs only. These are geometric progressions. Aren't they? Aren't they simple geometric progressions? If you observe your expansion as a geometric progression, then also there can be an approach to solve these type of questions. Geometric progression only, no? X to the power, x plus 3 to the power n minus 1. Just try dividing these two. Try dividing these two. X plus 3 to the power n minus 2 into x plus 2 divided by x plus 3 to the power n minus 1. N minus 2 minus n minus 1 will be n minus n minus 2 plus 1 minus 1. So this will become x plus 2 divided by x plus 3. Correct? And you see x plus 2 divided by x plus 3 is only being multiplied over here. Check the ratio of these two also. Check the ratio of these two. X minus 3 to the power n minus 3 multiplied with x plus 2 to the power 2 divided by x plus 3 to the power n minus 2 into x plus 2. This also is coming equal to x plus 2 upon x plus 3. Right? So this is basically a GP with first term given and common ratio given. First term is given, common ratio is given. First term is given, common ratio is given to you. So summation of coefficients of AR, right? If we just simply realize it as a GP, we can solve this very easily. Right? Try solving it with that particular method. So then everything can be found. For example, A, what is the formula for summation of GP? X plus 3, that means A, into 1 minus r to the power n, that means x plus 2 divided by x plus 3 to the power n, divided by 1 minus r, that means 1 minus x plus 2 divided by x plus 3. Now if we solve this, we will get x plus 3 to the power n minus 1 in the multiplication x plus 3 to the power n, x plus 3 to the power n minus x plus 2 to the power n divided by x plus 3 to the power n. And here in division, what are we going to get? X plus 3 minus x minus 2. So x plus 3 minus x, 3 minus 2, 1. This will become 1 upon x plus 3. Correct? Solve it more. X plus 3 to the power n minus 1. Now this is going to become x plus 3 to the power n, x plus 3 to the power n minus x plus 2 to the power n divided by okay, divided by this should cancel here. Why is it not cancelling? N minus 1 minus n plus 1 minus 2. Oh yes, 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 yes. This is getting cancelled. This will get multiplied to x plus 3 upon x plus 3 to the power n. X plus 3 to the power n minus 1 will be created over here. X plus 3 to the power n minus 1. Yes, this is getting cancelled now. This will go up and this will be x plus 3 to the power 1 minus n. Denominator mein again it will be x plus 3 to the power n minus 1. This is getting cancelled. Amazing. So simply, then that means your x plus 3, your sum of GP is nothing but x plus 3 to the power n minus x plus 2 to the power n, which is equal to your sum of coefficients, right? This is your entire GP sum. That means, right, this is your sum over here, right? This is your sum. Your entire series has become x plus 3 to the power n plus x plus 2 to the power n. This is your entire series has just become this. And actually in the starting also when we are expanding, we are getting this only. Correct? And in this alpha and beta, then we can compare, we can simply compare like this. Right, now you put your x equal to 1. In this, your summation of coefficients, this is your coefficient, no, summation of coefficient for r equal to 0. Now you put 1 on both the sides. This is equal to your alpha to the power n, something to the power n, beta to the power n minus gamma to the power n. This is your beta to the power n minus gamma to the power n. Now you put x equal to 1 over here. Sum of coefficients of x, right? X equal to 1. So now this will become 4 to the power n plus 3 to the plus or minus, yeah. Minus, it was minus. This is minus. So 4 to the power n minus 3 to the power n is equal to beta to the power n minus gamma to the power n. So beta is equal to 4, gamma is equal to 3. Directly we are getting, right? So realizing your expansion as a GP is going to be helpful. This is a great, amazing trick. Sometimes it will be really helpful. Look at your expansion. Whenever horrible looking expansions come, no, try seeing that can I form a GP over here, and then in the final term, I'll just input the values. Right? I'll just input the values in the final term. Because for this one now you can easily find the coefficient. Sum of coefficients here you can easily find. Here also sum of coefficients you can easily find, even if you want to find. In some question, even if that is needed, this observing your question as a GP will always help you. Chaliye. This again, this type of question, horrible looking, not horrible looking, but yeah, big expansion, big expression, and then its divisibility if they are talking about. Here they are saying 25 to the power 190 minus 19 to the power 190 minus 8 to the power 190 plus 2 to the power 190 is divisible by 14 but not 34, neither 14 nor 34, both 14 and 34 but not 14. How to solve these type of questions? These are very quick, these should be very quick questions. You cannot apply that divisibility method where we convert in the multiple of 34 or 14 and then how we'll be checking. Whenever you see powers are all same or are same in the couple, right? Either all powers are same or same powers are making pairs. Right? Suppose 2 powers are same, 2 powers are same. Here all 4 are same. So just remember that 25. Remember I told you that a to the power m minus b to the power n will always be divisible by a minus b. And similarly a to the power m plus b to the power m will be divisible by a plus b if m is odd. Here no problem. 25 to the power 190 minus 19 to the power 190. A minus, in minus there is no problem. It will always be divisible by 25 minus 19. Right? Similarly, 25 minus 19, minus 19, that means 6. Some 6 K1 it will be. Right? And if we look at 2 to the power 190 minus 8 to the power 190, or this is also divisible by mod of 2 minus 8, that means 6, right? Divisible by 2 minus 8, that means 6k. This is also divisible by 6. So this entire expression is divisible by 6. Right. Now if we create other couple, suppose if we do like this, 225 suppose if we create like this, 25 to the power 190 minus 8 to the power 190. So this will be divisible by 25 minus 8, that means 17. This is k2, let's say, right? 25, now other pair is 2 and 19. This is also making 17. 2 to the power 190 minus 19 to the power 190. This is also divisible by 2 minus 19, that means some 17k. This means that this expression is divisible by 6, and 17. Okay. 6 and 17, this is divisible by. Any other pair we are not able to make, right? Where will all the pairs we have made? 19 minus 8 we cannot do, right? 19 minus 8, both are in minus. So minus of 19 minus 8, 19 plus 8 it will become. And power is not odd. So we cannot comment about it, right? We cannot make other pairs. So we just know that this is divisible by 6 and 17. If 6 and 17, 6 can be written as 3 into 2. And 17 is a prime number, so 17. So in factors 3, 2 and 17, from this, can we make 14? No, we cannot make 14. We can make 34. 17 twos are 34. And 14 we cannot make. So it is divisible by 34 but not 14. This will become our correct answer. That means this expression is divisible by 34 but not 14, and simple. This is the simplest trick which you can apply in these type of questions. Remember that. Greatest integer and rational part and fractional part. This comes from the topic R factor theorem. This comes from the topics. These type of questions come from, very rarely you will get to see, but this year we got one question. This year, I think this year or last year, not sure. No, not this year. This year we didn't get. No, this year there was no R factor theorem question. I clearly remember. I think last or last to last year we got one question which was being solved from R factor theorem. Obviously longer approaches are there, but here if we use R factor theorem, it will be very helpful for us. Okay, so let's see how can we use the R factor theorem over here. How to use the R factor theorem? 8 root 3 plus 13. Okay, I'll show you for x, right? I'll show you for this part, and you'll be able to do it for the y part. What do we have to do? We have to say x is this, x is some expansion, okay? And if t denotes the greatest integer less than t, then integer part of x is odd, but integer part of y is even. Integer part of x, by any number n can be written as its integer part plus its fractional part. This you know, right? Any number n, this you should know, that any number n can be written as the sum of its integer part and fractional part. So here we just have to comment upon the integer part of this expansion and fractional part of this expansion. And these questions, if you don't do with the correct technique, they'll go very long. Okay, and you'll get lost in the solution also. So how to do these type of questions? What we'll do is we'll take x. This is our x. Let's say 8 root 3 plus 13 to the power 13. Now, this x number will have some integer part and some fractional part. Okay, this x number will have some integral part and some fractional part. Remember the steps. If you follow these steps, you will never get stuck in these questions. Next step is, what you do, you define some number g. Just define. You will define some number g. What will be g? G will be a number where we'll do 8 root 3 minus 13 or 13 minus 8 root 3, whatever is positive. In this case, 8 root 3 minus 13 will be positive or 13 minus 8 root 3 will be positive. 13 square is 169, 8 root 3 square will be 16 into 3, 198. So this will be greater. So you will do 8 root 3 minus 13. You are defining this number. You are defining this number. Okay. Now what you do? Now check. What should you do? Should you do x plus g or x minus g to get rid of the irrational part? To get rid of the irrational part. How will you get rid of the irrational part? Suppose if I expand x, so its expansion will be 13c0, 8 root 3 to the power 13 plus 13c1, 8 root 3 to the power 12 into 13 plus 13c2, 8 root 3 to the power 11 multiplied with 13 to the power 2, and it will keep going on like this. If you look at the expansion of g's expansion will be 13c0, 8 root 3 to the power 13, right, minus 13c1, 8 root 3 to the power of 12, 30 into 13 plus 13c2, 8 root 3 to the power of 11 into 13 square. Now you want to get rid of the irrational. Achha, whenever 8 root 3 will have even power, it will become rational. It will become integer. Whenever 8 root 3 will have integer power, even power, this 8 root 3 into 13, entire thing will become an integer. You want to get the rid of non-integer part. So how will you get? What should you do? X plus g or x minus g? Sir, I think we should do x minus g. Then only this 13 and 11, these parts will get cancelled, no? Right? So when I do x minus g, what will happen? 2 times, what parts will get cancelled? These odd powers of irrational numbers will get cancelled whenever I am doing. Right? And even powers, 13c0, 13c2, these terms will get cancelled where odd powers of your irrational number is coming. Which terms will get doubled? 13c1 into 8 root 3 into 12, 13 plus 13c3 into 8 root 3 to the power 10 into 13 to the power 3. All these terms are going to be integer terms because irrational number has even power. All these terms will be integer terms. So my x minus g is some 2 times of some integer. 2 times of some integer. That means x minus g is integer. Now after this, remember 2 things. If you get integer for x minus g, then this implies that your x is that means your f, that means fractional part is equal to g. That means your fractional part is equal to g. And if you get integer for x plus g, suppose you did x plus g and that is giving you the integer part, that means this implies that your fractional part plus g plus the g which you made is going to be equal to 1. These are the important things, right? Just remember this. If you are doing x minus g and then you are getting an integer, that means your fractional part is equal to g. If you are doing x plus g and then getting integers, that means your f plus g is equal to 1. Fractional part plus g is equal to 1. Okay. So here we are doing x minus g. That means our fractional part is equal to the g. If your fractional part is equal to g, that means this is what? X minus g. What is your x? Your x minus g, you know that your x minus g is your 2 times some integer, right? Integer. What was x? X was some integer, let's say this is I2, this is I1, some integer plus fraction, and so fraction minus g is equal to 2 times of integer part, correct? And we know that when we did x minus g, we'll get f is equal to g. So f and g will be equal. That means these will get cancelled. So I1, that means integer part of x. This I1 is integer part of x is 2 times the integer, is 2 times some integer. That means I1 is even. That means integer part of x is even. That means integer part of x is even. Very simple to say that. Okay ji. That means integer part of x is even. And I think similarly we'll get because here also 7 root 2 is greater than 9. No, 49 into 2, 98 and 9 9s are 81. Yeah, so this is greater. We'll have to do x minus g. X minus g will give us integer. That means y is also even. That means y is even. This is even. And integer part of x is also even. This is also even. Which option will be correct? This option will be correct. Even plus even will be even, right? Even plus even will be even. This is how you have to solve the fractional and integer part questions. Very important. Now let's pay attention at this question. Ah, my God. Please try solving this question. I'll take a small break. Chaliye, let's go. This question now. Also a repeated type of question. This came in 2021, 2023 and I think something similar to this. What are they asking? Simple question it is. Okay. But students think that there must be some other approach or some technique to solve this. There is no other or there is no separate technique to solve this type of question. You just have to be observative for this type of question, which is, what are they saying? This is saying 1 plus 1 by 10 to the power 100 to the whole power 10 to the power 100. What will be the lowest integer which is greater than this? It's simply asking what will be the lowest integer which will be greater than this particular expression. So we'll treat it like this. We'll treat it 1 plus 1 by x to the power of x. We know this. We'll treat it like this. So abhi, now if we expand this, what is the expansion? xc0, right? 1 to the power x, 1 by x to the power 0, right? Write the terms just for one time. I'm writing the terms, plus xc1, 1 to the power of x minus 1 multiplied with 1 by x to the power of 1. Or we should expand it, no, let's expand it like this only. Alright, plus xc2, right? 1 something, 1 by x to the power of 2, right? Plus xc3, 1 by x to the power of 4, 3, right? It will keep going on like this. Okay, ji. This will keep going on like this. Now, what is this? This is xc0 is 1, 1, this is also 1. So 1 plus xc1 is x, right? X, and this is 1, this is 1 by x. So this is also 1 plus xc2 something, xc2, let's say it is something, 1 by x square plus xc3, 1 by x cube, and this is going to go like this. Now what is this? This is 1 plus, this is also 1, 1 plus 1 plus. Now all these terms, all the 1 by x square, what is x? 10 to the power 100. So 1 by x square will be very, very small, correct? Smaller than 1 for sure. All these terms are smaller than 1. All these terms are smaller than 1. Can you see? 1 by x cube, x is what? 10 to the power 100 is x. So 10 to the power 300, 1 by 10 to the power 300 will be very small than 1. So this is going to be a big expansion, very big expansion, but this part will never exceed 1. So this will be 2 plus something, 2 plus 0 point something something, right? 2 plus 0 point something. 2 plus 0 point something, which will be the greatest integer. The question is lowest integer which is greater than this. Lowest integer which is greater than 2 point something. 3. 3 should be the answer. Lowest integer which is greater than this, and this is this will be always 2 point something. 1 plus 1 by x to the power x will always be 2 point something, because this part is going to be less than 1. 2 point something, lowest integer which is greater than 2 point something is 3. So very easily this question can be realized and solved. Just you should know that this is how you are supposed to solve this question. Now, coming upon how to find the greatest term in the expansion. Generally what we do is, we do tk plus 1 greater than equal to tk, and then we solve for k, and then we find k, and then we install it in your normal NCK, and then we'll be able to solve. TR plus 1 is greater than TR. That's what we use. But here one smaller and simpler technique which I have told in the sessions also. This technique is more efficient than solving like that. What do? We'll solve for tk plus 1 divided by tk equal to 1. Okay, for some k, right? For some k. Now, if your k comes out to be non-integer, if k is 6 point something, 5 point something, 4 point something, then simply t, integer part of k plus 1 will be equal to your greatest term. This will be your greatest term. Suppose your k came out to be 7.43, right? So integer part of k will be 7. So greatest term will be t 7 plus 1. That means t8. 8th term will be your greatest term if k is non-integer. If k is an integer, then both tk and tk plus 1, both of the terms will be your greatest term. If k comes out to be an integer, then tk and tk plus 1, suppose k came out to be 7, then t7 and t8, both will be greatest term. What happens is your binomial expansion goes like this. The terms first they increase, right? Then they decrease. So here can be one value, or max there can be two values. There will be two values will be same, and then it will start decreasing, right? See, this is how it happens. Coefficient. It is not about greatest coefficient. Greatest coefficient will be middle coefficient only, right? But greatest term can be anything. Greatest coefficient will always be middle coefficient, NC n minus 1 by 2, right? That will be your greatest coefficient, but greatest term can be different. For example, let's say these two example questions are there. 2 plus x, 3x to the power 9 at x equal to 3 by 2. What we'll do? First step, tk plus 1 divided by tk. We'll solve this. We'll put equal to 1. So tk plus 1 will be 9c k plus 1 divided by 9c k will be equal to 1. NCR upon NCR minus 1. Right? NCR upon NCR minus 1. This is that form, no? So 9 minus R will be k plus 1 over here. NCR upon NCR minus 1. Instead of R, we have k plus 1 divided by R. Right? This will be your, so this will become what? 10, minus 1 plus 1 to will become 0 only. So 9 minus k upon k plus 1. 9 minus k. And 9 minus k upon k plus 1 equal to 1. Let's see what is k. K plus 1 equal to 9 minus k. So this will become 2k is equal to 8, k is equal to 4. K is coming an integer. K is an integer, that means T4 and T5 will be the greatest terms. Simply. T4 and T5 will be the greatest terms. What is T4? T4 will be 9C3, correct? 2 to the power 6 into 3x to the power of 3. This will be your T4. And this will be same as T5 also. 9C4, 2 to the power of 5, 3x to the power of 4. And at x equal to 3 by 2 you have to find. At x equal to 3 by 2. Both will be the, we solved wrong here. Acha, sorry, my bad. This tk plus 1 only coefficients we solved. Sorry, my bad. We solved only coefficients. Tk means term. So there is something else also multiplied over here, na? 2 to the power 9 minus k plus 1 multiplied with 3x to the power k plus 1. This will be also easily solved, not a problem. Here 2 to the power 9 minus k and 3x to the power of k. This will be also easily solved, right? You can say when you're solving this, when you'll solve this, you'll get all these will can 9 minus k plus 1, n minus r plus 1, 9 by 4, this will become equal to 1. So your k, 13k equal to 90, k is coming as 90 by 13, which is a non-integer, 6.92. So we know in that case, t, integer part of 6.92, that means t6 plus 1, that means t7 will be greatest. T7 will be greatest, and T7 we can find 9c 6 2 to the power of 3 into 3x to the power of 6 when x is equal to 3 by 2. So 9 into 8 into 7 divided by 3 into 2 multiplied with 8 multiplied with 3 to the power 6 into 3 to the power 6 divided by 2 to the power 6. This will be your answer. Okay, must be over here. 336 into 3 to the power 7 will be your final answer. Chali. Numerically greatest also means the same thing only. You know, plus minus you have to calculate. For example, in this case, when we solved, k was coming equal to 4. Now there will be two terms, 4th and 5th. T4 is your minus of this and T5 is this. So which is the greatest among these two? Numerically, in magnitude, both are great. T4 and T5 both are equal. Right? T4 and T5 both are equal. Magnitude, if they ask, then both are equal. Numerically greatest, right? Positive term, something like that. When your k on solving tk upon tk plus 1, when your k is coming an integer, in that case you will get two terms which are greatest and are equal. Equal means in magnitude they will be equal. Chali, let's go ahead. Now in some questions this thing might not work. right? In some of the questions, this thing might not work. For example, try this question, read this question out. If n is an even positive integer greater than 1 and x is greater than 0, then the condition that the greatest term in the expansion of 1 plus x to the power n may have the greatest coefficient also. May have the greatest coefficient also. Come on. Try to solve this question. By n is an even positive integer, first of all, greater than 1 and x is greater than 0, then the condition that the greatest term in the expansion of may have the greatest coefficient also. But what do we mean by this? Right? What do we mean? That means, this means there is some term, right? There is some term tk, let's say that is the term tk. This should be smaller than tk plus 1 and this should be greater than tk minus 1. Yes, right? Then only this will be the greatest term, no? Because graph is always like this, increases and then decreases. So for any value which is greater than its previous value and smaller than, and greater than its previous value and also greater than its next value, right? Any value which is greater than its previous value and also greater than its next value, that will be the maximum value, because this is how the graph is going on, right? This is the main idea behind it. Okay, so we'll, from previous value it can be equal to also, greater than equal to we can also apply, because in some cases two values are equal, then we'll have to apply equal to also. But here let's solve without equal to. Let's see what case comes. Okay, so for t, now for 1 plus x to the power n, if we compare, the greatest coefficient and greatest term. Now, one main thing in this question which they are saying is, in these type of question they will say the greatest term has the greatest coefficient also, and greatest coefficient is always the middle coefficient or two middle coefficients. Greatest coefficient is always the middle coefficient. Middle coefficient. If the coefficient of the middle term is also the greatest term, I mean the greatest term also has the greatest coefficient. Greatest coefficient will always be the middle coefficient. In NC0, NC1, NC2, NC3 till NCn, NCn minus and NCn minus 1 by 2 will be the greatest, or n plus 1 by 2, right? But middle one will be the greatest. That is the idea. So middle coefficient, middle coefficient in case of even terms. Suppose there are 5 terms. So suppose if n is 5, then number of terms will be 6. If n is 6, then number of terms will be 7. Correct? If n is 6, if n is even, number of terms will be 7. Yes? Getting my point or not? Then the greatest term will have coefficient of NCn minus 2, and x to the power will also be n minus 2 in that case, right? Coefficient of greatest term. Coefficient of greatest term will become what? Coefficient of greatest term. Because n is even. If n is even, that means number of terms will be odd. So n plus 2 by 2, right? So n by 2 plus 1 will be your greatest coefficient will become what? NC n by 2, right? And x to the power will also be n by 2. Now this will be your greatest term. This becomes your greatest term. This should be greater than the previous term and smaller than the other term. So this thing x to the power n by 2, sorry, nc n by 2, x to the power n by 2, right? Nc n by 2, half of that, right? Middle term. By in 6, if suppose it is n is 6, so in 7 terms, which will be the middle term? Fourth term, no? Yeah. N is greater than 1 and no, wait, something is wrong. Yeah, correct only. NC n by 2 only. NC n by 2 only it is coming, no? NC n by 2 only is coming. Right, this will be your greatest term. This should be greater than the previous term. That means NC n by 2 minus 1 x to the power n by 2 minus 1. Right, and this should also be greater than this NC n by 2 x to the power n by 2 should also be greater than the next term, which is NC n by 2 plus 1 x to the power n by 2 plus 1. We'll solve these two inequalities. X will, everything will get cancelled. So n minus r plus 1 only will appear. Let's see. Right, this, yeah, n minus r plus 1. When we'll solve this, yeah, see, when once we'll solve this and once we'll solve this. This will give us n minus r plus 1 upon r, right, greater than, so x will come greater than this and smaller than this. This is how we are going to get our answer. Right, so only in these type of questions you will have to go for the core method. Otherwise, tk upon tk plus 1 upon tk will always work. Put tk plus 1 upon tk equal to 1 and that thing will always work. Only these type of questions where they have given the inequality in itself, there you might have to think in that way, that middle term, if they are saying coefficient is greater, then middle term's coefficient will be greatest. These things, some special, these type of expansions should be in your head by hearted. 1 plus x to the power minus 1 is equal to 1 minus x plus x square minus x cube plus x to the power 4. 1 minus x to the power minus 1. Here minus gets multiplied and everything becomes plus. 1 plus x plus 2x square. 1 plus x square plus x cube plus x to the power 4, like this. 1 plus x to the power minus 2 is also sometimes very used in questions. It is 1 minus 2x plus 3x square minus 4x cube plus 5x square, like that. Plus minus will go here. Here again 1 plus 2x plus 3x square plus 4x cube, like this. Right, so these expansions should be in your head. For example, these type of questions. This is what, 5 into 1 minus 2x to the power minus 1 and this is 1 minus 3x to the power minus 1. So you will multiply 5 and this expansion will become 1 plus 2x plus 2x square plus 2x cube. It will go like this and this will 1 plus 3x plus 3x square plus 3x cube. It will go like this. Right? So directly, if you remember this, you can expand very easily. Otherwise, you know, with binomial, it will take a lot of time. So 5. Now coefficient of x square they are asking. So x square will be generated by multiplying 1 and 3. 1 and 3x square. So 3 plus a 2x square with 1 plus 2. Right? Plus 3 into 2 when we multiplied, x square will be generated. This. So 55 will be the coefficient of x square. Should be. 19 कैसे? 9 plus 6, 9 plus 4, correct only we did, no? Acha, sorry. Square, no? Squares. So 9, this will be 9, this will be 4, yes. This will be 9, this will be 4. 15 plus 4, 19 into 5, 95. Yes, 95. Square, no? 2 square will be there and 3 square will be there. And then this 3 into 2, as it is, 3 into 2, 6. So these type of expansions, directly keep them in your head so that if this type of question comes, you can easily solve it. Coefficient of x cube. In this case, come on, can somebody tell me very quickly? coefficient of x cube. You can expand also if you want. You can expand also till, I told you till -2 powers, till -2, nahi? Right. -3 you'll have to expand like that. If -3 comes, then also don't be afraid. Its expansion will happen like this. I'll show you. 1, this expansion we are doing. 1 plus 3x square. Sorry, minus is the power, so plus minus it will go. Here there is plus, there is minus, so plus minus it will go. So 1 minus 9x, then plus -3 and -4. Next number divided by 2 factorial. Then -3, -4, -5. 3 numbers, so 3 factorial. Then -4, -5, -6. Sorry, -3, -4, -5, -6 divided by 4 factorial. It will expand like this. Right? This is the expansion. 1 minus 9x plus 54x square, x square plus 27x cube. You can simply expand like this. Right? X square, all that will go like that only. Remaining things will work in the normal way only. Thank you, boss. Thank you. This again, one question. Same, with the same way we are solving this. This came in 2021. But you see, these expansions, this is what? A minus b to the power -1. This is a minus b to the power -1. This is a minus 2b to the power -1. A minus 2b to the power of -1. This is a minus 2b to the power of -1. Hey, this should be 3b here. Here should be 3b, I think. Okay, whatever. Right, now you expand, and what is it saying? So that the cube of b is very small, so we can ignore the cube of your b cube and the higher powers. It is saying higher powers of b by a can be neglected in the identity. So we'll create b by a over here, divide by a. So a, if we take common, a to the power -1 will come out common from this, and 1 minus b by a to the power -1 will be this. Right. Similarly, this will be a to the power -1, a 1 minus 2 by b, 1 minus 2b by a to the power -1 will be expanded. Right. So if you see over here, okay, this expansion is going to become like this. A 1 by a is taken, a to the power -1 will become 1 by a. So 1 by a we have taken common. Sir, would you be doing this for the another chapters like calculus and conics too? Ha, bete. Yes, Ravin, I'll do. Py cube, all the things where important things can be taught, I'll be doing that. Right. So 1 by a summation of these terms, 1 minus rb by 1. Now if you expand this, this simply will be expanded 1 plus rb by a plus r square b square by a square. This will be the expansion, and cube powers, the question already told. So higher powers than 3 can be neglected. So we have to neglect all the other powers. We'll open this simply. And what you had to compare? You had to compare it with this and find this. So only cubic term you had to compare, and gamma will be directly found. So when you open this, your cubic n cube will be equal to b square by 3a square. So gamma is b square by 3a cube. Direct answer you will be able to get. The only hint, why am I making you do these questions? We have done this in another classes also, but I'm saying that the simple sum of the expansion should be there in your head. Otherwise, if you expand and solve with the normal binomial expansion, it will take a lot of time. It is going to take a lot of time, especially with negative powers. So remember these simple expansions, right? At least till x minus 1 minus x to 1 plus x to the power -1, 1 minus x to the power -1, 1 plus x to the power -2, 1 minus x to the power -2. These much you should remember, and if -3 also, if you can remember, that will be great. Chali, let's come upon the next part, which is matrices. In matrices right now, these days, from last 2-3 years, combination of matrices with limits and combination of matrices with permutation and combination has increased. Right? This has increased. This question we have solved earlier also. Try to give the answer if you can. Permutation combinations, they are using a lot with matrices nowadays. Number of symmetric matrices of the order 3 with all entries from the set. With all entries from the set. How to do that? Symmetric matrices. But in skew symmetric, we know that diagonal elements will be 0, 0, 0. Right? You should know. In skew symmetric, sir, sets and functions, one shot. Sets and functions, okay. Right? A. Okay, let's see. In the diagonal element, in skew symmetric, diagonal elements will be 0, 0, 0. But here they are asking about symmetric matrices. So symmetric matrix is what? Here for these, this and this. For diagonal can take any of the values, all the 10 values. Diagonal can take all the 10 values. So for this 10 options, for this 10 options, for this 10 options. Now these values, we are talking about these values over here one, over here one, over here one, over here one. Whatever is coming here will be here also. Whatever comes here will be here also. Then only symmetric, no. Whatever comes here will be here also. Then only we'll be able to make symmetric matrix. Otherwise, how will you make symmetric matrix? So what 10 choices for this. But whatever is coming here will come here. So no, only one choice for this one, because this is fixed. 10 choices for this also, 10 choices for this also, but for these one choice only, because whatever is coming here will come here. Whatever is coming here will come here. Then only this will be a symmetric matrix. So now this is a symmetric matrix where how many 10s we have? 1, 2, 3, 1, 2, 3, 1, 2, 3. 10 to the power 6 will be a correct answer. 10 to the power 6 should be a correct answer. Very good, Ravin. Right. A better version, a difficult or trickier version of this came this year. This is 2025 question only. A better version of this type of matrix came this year. Here what is it saying? Let's see. Let M denote the set of all real matrices of order 3 and 3 cross 3 and S is equal to this. Then let S1 equal to be a matrix where the matrix is of Aij and A is equal to A transpose. A is equal to A transpose. A equal to A transpose means what? Symmetric. A equal to A transpose means that we have to make a symmetric matrix. Okay. Hi Ravan. Acha, you guys are talking. And Aij all belongs to the, alright, no problem. Aij all belong from, now all the elements of this matrix will belong from the main set, which is S. And A should be a symmetric matrix. Now this means symmetric. So how will we make symmetric matrix? Just now we made. So now how many elements? 1, 2, 3, 4, 5. Right? 5 elements we have. So we know to make a symmetric matrix 5 to the power 6 directly. Shall I say 5 to the power 6? Right? For this will be S1. So number of elements in S1 will be 5 to the power 6. Correct? There are 5 to the power 6 ways. Because 5 elements are there. 5, 5, 5, 5, 5, 5. 5 to the power 6 choices will be there. 5 to the power 6 ways will be there. Using these 5 elements, I can make a symmetric matrix. Okay. Now for the second part. Second part, A is equal to minus of A transpose means skew symmetric. This means skew symmetric. This means a skew symmetric matrix. And in skew symmetric matrix, diagonal elements are definitely 0. Otherwise, we cannot get a skew symmetric matrix. And these remaining elements, the conjugate elements, will be in opposite signs. Will be opposite of each other, nothing else. Opposite of each other. Opposite of each other. So, here the problem is we cannot make a 3 cross 3. Wait. 1 for 1 minus 1 is there, for 2 minus 2 is there, for 1 minus 1 is there. For 1 there is minus 1, but I think some element is missing. Yeah, for 3 there should be minus 3. Yeah? Don't you think so? For 3 also there should be minus, but, no, wait. Arey, we don't have to make S2. Look, 0 is not there in S2 only, no. 0 is not there in S. So S2 cannot be made. Number of elements in S2 will be equal to 0. Why? Because for making a skew symmetric matrix, for making skew, or I can simplify it, for making a skew symmetric matrix, you need 0, 0, 0 in the diagonal. But 0 is not there in the S. 0 does not belong to S. Simply. That is why there will be no middle term should be 0. Diagonal element should be 0. So there is no 0 in S. I was thinking about where is 3. There is no 0 only. Okay. Now S3. S3. A11 plus A22 plus A33 should be equal to 0. Achha, this will have to make. So A11 plus A22 plus A33 should be equal to 0. That means diagonal elements. That means sum of diagonal should be equal to 0. So how all can we do that? 1, 1 and minus 2 can do it. Plus 1 and minus 2 all are there. 1, 1 and minus 2 we have, right? 2, 1 and minus 3 also can do it. 2 is there, 1 is there, minus 3 is there. How else can we get 0 in the diagonal elements? Diagonal elements. How else can we get 0? Tell me the ways. Come on, guys. Bro, nice. I live in Vizag. Achha, these. 1, 2 minus 3 is there. 1, 1 minus 2, or one more method is there, I think. 1, 2 minus 3 we wrote. 1, 1 minus 2 we wrote. Minus 1 and 2 also will do it. No? Minus 1 and 2. Any other approach? Any other method? Come on, tell me, guys. Any other approach? Can there be any other method? Right? Now, for S3, right? Diagonal elements can be these only. Diagonal elements can be 1, 1 minus 2, 2, 1 minus 3, or minus 1, 2. But there can be arrangement of these. These are 3 elements. Right? There can be arrangement of these. Arranging these 3 in 3 places. 3 into 2, 6, 3 into 2, 6, 3 into 2, 6. Right? So total method. And for the other places, there is no restriction. For other places, there is no restriction. So 6 places are left. So 5 to the power 6 will be for the other places. All will have 5, 5 choices. All will have 5, 5 choices. Correct? And for these three cases, which should be there in the diagonal, arrangement of this will be 4 into 3, that means 12. So 12 multiplied with 5 to the power 6 will be your S3. That means these many elements will be there in your S3. Now, it is talking about this. Number of elements in S1 intersection, S1 union S2 union S3. In union of S1 with a null set, S2 is null. S2 is null set. So, union of S1 with a null set will be S1 only. So, this one, this n of S1 union S2 union S3 is nothing but number of elements in S1 union S3. Number of elements in S1 union S3. Correct? Which is given by number of elements in S1 plus number of elements in S2 minus number of elements in S1 intersection S3. Which elements will be there? How many elements will be there in S1 intersection S3? By 5 S3. What was S3? S3 came out to be 12 into 5 to the power 6. Right? Which cases will make it symmetric also? 5 to the power 3 cases will make it symmetric. 12 into 5 to the power 3. I mean, S1 intersection S3 means what? That its diagonal element sum should be 0 and it should be symmetric. It should be symmetric. That means this thing is nothing but 12 for diagonal elements to be 0. 12 methods to make diagonal element equal to 0. Right? And for making it symmetric, 5 to the power 3. Only these we can fill. Correct? So totally our answer becomes n of S1. That means 5 to the power 3. नहीं, कितना था? 5 to the power 6. Right? 5 to the power 6 was n S1 plus number of elements in S2 and number of elements in S3. Number of elements in S3 came out to be 12 multiplied with 5 to the power 6 minus 12 multiplied with 5 to the power 3. This will be your answer. Only this thing will be your answer. Okay. So take 5 to the power 3 common. Simply, what was the question? This was equal to 125 alpha. This is equal to 125 alpha. So 5 to the power 3 you can take common. This will become 5 to the power 3. This will become 12 into 5 to the power 3. This will become minus 12. So 125 got cancelled. So alpha is nothing but 125 plus here is a plus 125 into 12 minus 12. This big sa thing, it is calculated. So 13 into 125 you can directly do. 13 into 125 minus 12 it will become. No? This will be your answer. This we did, right? This question we did. This question we did. Now this question. Orthogonal matrix questions are very common, and because orthogonal matrix students don't study very minutely or very descriptively. That is why orthogonal matrix questions also are the favorite of mains. In orthogonal matrix, just remember two things: row wise or column wise magnitude. If we find, for example, this is your matrix A1, A2, A3, B1, B2, B3 and C1, C2, C3. This is orthogonal matrix, right? It is given A transpose equal to I means A is orthogonal. A is orthogonal. Right? If A is orthogonal, then three things we know: that determinant of A will be equal to plus or minus 1. One thing we know is that if A is an orthogonal matrix, then determinant of A will be pakka plus or minus 1. Another thing is, Ravan says 2p square is minus 1. Very good. Right? Another thing which we know is that their magnitude, column wise magnitude, that means A1 square plus B1 square plus C1 square will be equal to 1. Also A1 A2 plus B1 B2 plus C1 C2. The vector dot product will be equal to 0. The vector dot product will be equal to 0 and column wise magnitude will be equal to 1. So for example, in this case, column wise magnitudes will be 0 square plus p square plus p square should be equal to 1. That means 2p square should be equal to 1. That means p square is equal to 1 by 2. That means p, determinant of p will be 1 by root 2. If you know these properties, then only you will be able to solve this question. Otherwise, you will multiply A with its transpose and then create a 3 cross 3 identity matrix, and then I don't think you'll be able to find even in that case. Answer will come, but main thing is that you should use this, right? Magnitude column wise, row wise, or that's dot A2, A3 plus B2, B3 plus C2, C3 will also be equal to 0, right? That will also be equal to 0. Dot product of columns will be equal to 0, or row in rows if it is given, then in that case also. That is the beauty of an orthogonal matrix. These type of questions, again, this is also based on orthogonal matrix only. A1, A2, this is what? A1, B1, right? A2, B2, A3, B3. Sum of A1, B1, A2, B2, A3, B3. A1, B1, A2, B2, A1, B1 plus A2, B2 plus A3, B3. Right? This is equal to B1, C1, B2, C2 plus B3, C3. Equal to A1, C1, A2, C2 plus A3. All are 0. That means this is orthogonal. If this is also true and this is also true, this is also true. A1 square plus B1 square plus C1 square. A1 square plus A2 square plus A3 square. B1 square plus B2 square plus B3 square. C1 square plus C2 square plus C3 square is equal to 1. That means this is a completely orthogonal matrix. So A into A transpose will be equal to identity. Or simply determinant. Here you don't have to use that. Here what are they asking? Determinant. Determinant, since A, determinant of A will be equal to plus or minus 1. Determinant of an orthogonal matrix is always equal to plus or minus 1. Remember that. Okay. JEE often asks questions on adjoint and orthogonal matrix. 3 types of questions I found very common in all the papers. One is your orthogonal matrix based questions. Another is your determinant infinitely many solutions. Those questions are repeated every year. Every year they are repeating those questions where you find the conditions for condition for 3 equations to have infinitely many solutions, which you solve using determinant. Other than that, yeah, this is one variety which was also very common, but this too you can solve very easily. Other than this, what did I find? We'll see. We'll see. We'll see. Okay, this is also one variety which is being repeated. Right, Q is equal to P into A into P transpose. P will be given to you, A will be given to you, some information about Q will be given to you, then 2A plus B minus 3C minus 4D, they are asking you to find. Come on, give it a try. I'm sure this, even if you have solved a matrices in NCERT, you should be able to solve this one. Pay attention at P. Again, please pay attention at P. What is P? Does P look like a special thing to you? Does P look like a special thing to you? If that you did know, then the question has nothing to do. Right? Whenever these type of things which involve transpose and matrix, whenever you see a matrix being multiplied with a transpose and the matrix is given to you, always check whether the matrix is orthogonal or not. Here, check root 3 by 2 into 1 by 2 plus minus 1 by 2 into root 3 by 2, 0. Dot product is 0. Magnitude root 3 by 2 whole square plus 1 by 2 whole square, 1. Right? So this means that P is orthogonal. Here only catch is P is orthogonal. That means P into P transpose will be equal to I of order 2. Identity matrix of order 2, because P is of order 2. Then everything is done. Then there is no problem. Then you can solve this question. Let's see. So P and A, P into P transpose will be your identity matrix. P into P transpose. So here you can take transpose on both the sides if you want. P transpose into P will be equal to 1. Q to the power 2007. You can write as PAP to the power 2007, PAPT to the power 2007 times. We are just multiplying. A is your identity matrix. It is already given over here. A is your not identity matrix. A is not an identity matrix. But powers of A will be very easy to, A square, A cube, all these powers of A will be very easy to manipulate. So A to the power 2007 will be nothing but 1 2007. When you observe the pattern, A square has 1201, A cube has 1301. So A to the power 2007 will have 1 2007, 0 and 1. Okay. So A to the power 2007, you have P into P transpose, you already told. Taking, this is how you can easily solve these type of questions. Just observe your matrix very carefully. Then this type of questions, this year also many questions came on this type. Some formulas which you should remember. I think I have, wait, let me check, yeah. Some formulas related to adjoint should be very handy. First of all, A into A adjoint, A multiplied with adjoint of A is given to you by A, determinant of A multiplied with an identity matrix of order n. Right? We start from here. Then some properties like these. For example, this determinant of adjoint of A. Right? We know that A times adjoint of A will be equal to determinant of A multiplied with some identity matrix. Okay, multiplied with some identity matrix. Now, if we take determinant both the sides, suppose if we take determinant both the sides, so this will be determinant of A, determinant of adjoint of a determinant breaks in the product is equal to this A times identity matrix. Determinant of A is a scalar quantity, right? It is multiplied with an identity matrix. That means this, if I want to take this determinant out of the determinant, a scalar quantity, a constant, determinant of A is a constant. Determinant of A I am taking out of a determinant which is of order n. So determinant of A to the power n will come out and determinant of identity matrix of order n will remain. So now from here what do we get? Adjoint of A, determinant of adjoint of A, determinant of identity matrix will be equal to 1 and this will become determinant of A to the power n minus 1, right? This will go in division and we'll get determinant of A to the power n minus 1. This derivation, if you can remember, then you can solve all of these very easily. Here, this also will start from there only. The second one, adjoint of A will be determinant of A. This adjoint of A will be a matrix only. So this will be, thank you Monique, adjoint of A. This will be equal to determinant of A to the power n minus 2 multiplied with the same matrix. Love you too, Malik. Adjoint of A, determinant of adjoint of A will be determinant of A to the power n minus 1 whole square. All of these you can start from the main method, which is A adjoint of A equal to determinant of A multiplied with identity matrix. From there only all these are coming, right? All these are coming from there only, nowhere else. So these questions also based on adjoint questions are being repeated. Let's see. This question as we saw. So first, solve step by step. First, adjoint of this entire thing. Adjoint of this entire thing, right? So, or what you can do, let's do this. 3 adjoint of this determinant of 3a to a square. Correct? Now, what does this look like? Determinant of this. 3 has to come out of the determinant. Right? 3 has to come out of the determinant. Determinant will also be of 3 cross 3. So 3 to the power 3 will come out. 3 wants to come out of the determinant. So 3 to the power 3 will come out of the determinant. Right? Adjoint of 3. Now this 3 also wants to come out of the determinant. This 3 also wants to come out of the determinant. So 27 determinant of a square. Correct? Now this 27 wants to come out of the adjoint. Adjoint of, we saw this rule, no? Adjoint of this rule. Adjoint of A. Or adjoint of A. If you adjoint of A will be determinant of A to the power n minus 2 times A. Correct? And determinant of adjoint of A will be determinant of A to the power n minus 1 whole square. Now here you think, what should be our next step? Adjoint of this or determinant of adjoint of this, right? This will be 3 to the power 3. Determinant of adjoint of this means 27, or let me write like this only. Directly 3 we have taken out, 3 to the power 3 came out. Now adjoint of something or determinant of adjoint of A. Determinant of adjoint of A is determinant of A to the power n minus 2. Correct? Determinant of A to the power n minus 2. These formulas only are working. These formulas only are working. Determinant of adjoint of A will be determinant of A to the power n minus 1. Okay. So now this determinant, entire determinant, if I want to open, this will become determinant of 27. Let's solve from here again. Leave it. Right, 3 first I have taken out. 3 I have to take out. 3 to the power 3 will come out. Then determinant of adjoint of this entire thing. 3a determinant a square. Right, a square. This entire thing's determinant. So this entire thing to the power n minus 1 will become, no, 3 to the power 3 determinant of 3a a square to the power n minus 1. Right? Suppose this entire thing was a only. Just treat it as one entity. So determinant of adjoint of A will be determinant of A to the power n minus 1. Right? N is 3. So this will become 3 minus 1. That means 2. Correct? Now, 3 will come out of this determinant. Right? 3 will come out of this determinant. That will be, that will make 27. Right? Sorry, wait. This 3 will come out of this determinant. That will make 27, and 27 into this will make 24. 54 multiplied with 2 also, because power is 2. Right? Because the power is coming out to be equal to 2. So this will become 54 A square and determinant square. Right? This will become 54 A square and determinant square. So 3 cube into this will become 54 determinant of A square and whole square. Okay, ji. Any problem here? Step by step, try solving it. You will be able to do it very easily. Now we will have 3 to the power 3 into 54 to the power, 54 is coming out of determinant. So 54 to the power 2, sorry 54 to the power 3 multiplied with this 2, because power over the determinant is also there. So 3 to the power 3 into 54 to the power 3 into 2, that means 6. Okay, and determinant of A to the power will become 4. Determinant of A to the power will become 4, and I think determinant of A is given to you. Actually, if determinant of A is given to you, here only we could have put determinant of A, but it's okay, leave it. Right? It's okay, leave it. Direct A to the power 4 we have done. So this will be your answer. 3 to the power 54 has 3 is right. 9, 6. 27 into 2 is 54. 3 to the power 3 multiplied with 3 to the power 3. 3 to the power 6 into 9. 8 will come. Which answer is matching? 3 to the power 11, 6 to the power 10, I think. This should match. Right? 2 to the power 4 also we have, no? Because determinant of A is 2. So 3 to the power 11, 6 to the power 10 is matching. This is also 2 to the power 4. Okay, this is how. So these questions, practice some more. Okay, I'm not saying, I'm just showing you this particular variety is repeating itself in JEE. This year also many questions came on the properties of adjoint only. Many questions came on the properties of adjoint this year also. Okay, let A be this determinant of, again same type of question. First, take this 2 out of the determinant. 2 out of the determinant is of order 3. So 2 to the power 3 will come out. Now, determinant of adjoint of 2 times adjoint of 2A. Okay, now this 2 out of the adjoint. This 2 I want to take out of the adjoint. That will, these properties I didn't show you. Few more properties are about here. Now look, when you take the constant out of the adjoint, constant to the power n minus 1 will come out, right? So that is what I am implicating. Constant to the power n minus 1 will come out. There is a constant inside this adjoint. So 2 to the power 3 minus 1. That means 2 to the power 2 will come out. 2 cube, determinant of 2 to the power 2, adjoint of 2A. This will become. Okay. Now 2 to the power, this 2 to the power 2 to the whole power of 3. That means 2 to the power 3 into 2, this 2 to the power 2 coming out of the determinant which has the power 3. So 2 to the power 2 to the whole power 3, that means 2 to the power 6 will come out, and here we'll have adjoint of 2A. Determinant of adjoint of A will be determinant of A to the power n minus 1 whole square, right? So this will be 2 to the power 3 into 2 to the power 6 multiplied with determinant of 2a to the power n minus 1 whole square. That means 3 minus 1, 2 square 4. Okay. 2 coming out of the determinant will have 2 to the power 3 and 3 to the power 4 will be there. So 2 to the power 3 into 2 to the power 6 into 2 to the power 12 into determinant of a to the power 4. Determinant of a is also 2. So this will become 2 to the power 3 into 2 to the power 6 into 2 to the power 12 into 2 to the power 4. Oh ho ho ho. So this becomes 6, 7, 8, 9. 16 plus 9, 25. 2 to the power 25. I hope we solved correctly. 2 to the power 25 is equal to 2 to the power 5n. 32n means 2 to the power 5n. So n will be equal to 25 by 5. That means 5. N is equal to 5. What is alpha? Acha, alpha we'll have to find by solving the determinant. So, solving the determinant, there must be solution. N is equal to 5, no? N is coming out to be equal to 5. Check once. And alpha is coming minus 4. So 3n plus alpha will be 15 minus 4. Correct. This question again, you can simply see this is related to binomial expansion. This is your binomial expansion. This I plus, this question also we have solved. Look at this question again. This, they'll relate your matrix to a binomial expansion, but you don't have to worry. This is I minus adjoint of a to the power 5 expansion. So you just have to do I minus adjoint of a. The sum of all the elements of this matrix. Right? Sum of all the elements of this matrix you have to do. Find I minus adjoint of a. Adjoint of a you must be able to find. I minus adjoint of a and its power 5. And sum of the elements of matrix B you have to find out. So B will come out to be this. You just have to observe that they can relate your matrix and binomial expansion. This is very common practice. Many times we have seen this type of questions. Then this is repeating every year from 21, all the so many questions. If you'll go on PYQs of matrices and determinants, you'll keep seeing this. You'll keep seeing this, that infinitely many solution. Or so simple thing, determinant of, suppose your equations are like this, a1, once I'll teach you, I hope you know this already, a1x plus a2 plus b1y plus c1 is equal to d1. a2x plus b2y plus c2 is equal to d2, and a3x plus b3y plus c3 is equal to d3. These three are your equations. Simply do this. Now normal method is that this determinant a1 a1 a2 a3 b1 b2 b3 c1 c2 c3. This is called your delta. Now if delta is not equal to 0, right? If delta is not equal to 0, in that case you are going to get, if delta is not equal to 0, in that case you will always get unique solution. But if delta is equal to 0, either you will have infinite solution or you will have no solution. For infinite solution, the condition is very simple, but depends on the value of delta x and very good. Yes, in infinite solution. Now there are three things: delta x, delta y, delta z. For example, delta x is, instead of x coefficients, you wrote the constants. That means d1, d2, d3, right? b1, b2, b3 and c1, c2, c3. This is your delta x. And similarly, you will have delta y. In delta y, this is not a1, a2, a3. This is d1, d2, d3. Right? Similarly, in delta y, you will have this. In a1, a2, a3 will be there, but coefficients of y will not be there. Instead of that, d1, d2 and d3 will be there. And these will be same, c1, c2, c3. Correct? These will be same. This will not be equal to, this will be delta y. Now, in case of infinite solutions, your delta is equal to 0, delta x, delta y and delta z all are equal to 0. But in case of no solution, delta is equal to 0, but delta x is not equal to delta y and they are not equal to 0. Okay, all three are not mutually equal to 0. This is the simple theory of this particular type of questions. Now let's come on to how to solve, how to efficiently and within time solve these type of questions. Okay, so simply if it is saying infinitely many solutions, then don't go for delta. First suggestion is, my first suggestion is, don't go for delta. Don't create delta over here. That means don't make this 1, 2, 14, 2, lambda, 3 and minus 3, 5 and mu, right? Don't put this equal to 0. Don't do that. No, don't do that. You'll get stuck. Right? And you'll calculate more. Directly use delta x or now in this case, you need to find mu and lambda. So directly, wherever you see variable, whatever you need to find, so directly find delta z and delta y and put this equal to 0, this equal to 0. Delta z equal to 0 means, delta z equal to 0 means just hide this 1, 2, 14, 2, lambda, 3 and 2, 5, 2, 5, 33. Right? Or even in simpler words, if I ask you to, if you want to solve this question faster, then make a hypothetical determinant which will be like this: coefficients of x 1, 2, 14, coefficients of y, which is 2, lambda and 3, coefficients of z, that is minus 3, 5 and mu, and one more column over here 2, 5 and 33. Now what do you need to find? Mu and lambda. Once just hide this. Once just hide this. Just hide this once. Except this, solve the other determinant. That means 1, 2, 14, 2, lambda, 3 and 2, 5, 33. Make this equal to 0 and in other step hide this. That means 1, 2, 14, minus 3, 5 and mu and 2, 5, 33. Directly put this equal to 0. With these two, you'll directly get lambda and mu. If you go for delta equal to 0, you'll have to calculate a lot and you'll get a product of delta mu. Here you're directly getting delta and mu. In this you'll get delta, in this you'll get lambda, in this you'll get mu. Directly lambda and mu we are getting. So this is the approach I would suggest, that if question comes like this, solve like this, because question can be as complicated as this also. So you directly make infinite, and most of the times they'll give you infinitely many solutions only. 99% of the times they are giving you infinitely many solutions. So here your delta x, which will be equal to what? Delta x will be equal to 579, correct? And 579, lambda minus 4, lambda minus 1 and lambda plus 2. And here we'll have lambda, lambda minus 4, lambda minus lambda plus 2. This determines 0. Right? So lambda square plus lambda, like this you are going to get. Right? Question can be complicated, but approach, if you know, you will be able to solve. Limits. They also have started putting limits in your matrix. So standard limits, I would suggest that you should revise once. For example, limit of x tending to 0, sin x by x, this is equal to 1. Right? These are standard limits. Standard limits you should know. So this type, if you know this, then you can easily solve this. No, limit of function. Now this is your function. Your f of x is this. If you put limit x tending to 0 on f of x, this will become what? This determinant will become what? A plus 1, 1, b, a, 1 plus 1, that means 2, b, a, 1 and b plus 1. That's it. This is what your determinant will become. Right, when you solve this, it will come like this only, then compare the coefficients and give your answer. So they can integrate limits. So standard limits you should revise, don't worry, in metrics they can do like that. This question again, x transpose A. Achha, this type of question we solved no, just now. On the properties, this question again is just about the properties. A, B, adjoint of A inverse. Now look, we should know that A, B inverse is equal to B inverse into A inverse. This property only is being used over here, but that they just made it look so much complicated. A, B and adjoint of A inverse plus adjoint of B inverse. This complete thing is a matrix, right? Are non-singular matrices of same order, then you have to calculate this. You have to calculate the inverse of this. That means inverse of A, adjoint of A inverse plus adjoint of B inverse. Now they'll always, what I'm trying to say is, they will always try to scare you out. Not array, how will we find the inverse? So much of properties are being used over here. Only one property is being used. Only one property is being used, which says, which is AB whole inverse is B inverse into A inverse. O A inverse equals adjoint of, nahi, A inverse, nahi, not that. Actually, I have written it, maybe I didn't write it very neatly. This is A. A is being multiplied with this entire thing. That means adjoint of A inverse, correct, plus adjoint of brackets. Pay attention on brackets. Adjoint of B inverse, right? A is getting multiplied with this entire thing first. A is getting multiplied with this entire thing's inverse. A is getting multiplied with this entire thing's inverse, and then this is being multiplied with B, correct? So this over here, what you have to pay attention, without getting scared, you just have to pay attention at this, that this is one term, and then we are finding the inverse of this entire thing, inverse of this entire thing, product. Now this entire is your A, let's say, and this is B. So product whole inverse will become B inverse, will come in the front, and inverse of this A into adjoint of A inverse plus adjoint of B inverse whole inverse. Getting my point? Yes or no? Correct. So now B inverse will remain as it is. Now again, A multiplied with inverse of something, this is one, again one term, this is one single term. A multiplied with something, whole inverse, will give us what? This inverse of inverse. A inverse, inverse of A inverse will be A only. So that means here we'll again get adjoint of A inverse plus adjoint of B inverse, correct? This thing will come as it is, and A inverse will be multiplied. Now, because inverse of this inverse will be this term only. Okay. So I think answer came, no? A inverse is 1 by determinant of A. B inverse is 1 by determinant of B. Huh? Correct? This answer is coming now. This A inverse is 1 by determinant of A. Adjoint of A, determinant of A. By B inverse will be what? B inverse can be written as A adjoint of B inverse divided by determinant of B inverse. Correct? Determinant of B inverse and determinant of B will be same only. Correct? And adjoint of A inverse can be written as adjoint of, adjoint of A. adjoint of B divided by determinant of B multiplied with adjoint of A divided by determinant of A, and this thing multiplied with adjoint of A inverse plus adjoint of B inverse. So this again will come. Clear? Same thing will answer will be this. Answer is already written. The only thing is that only one property is being used, but they made the look. So here only game was of these brackets. If you pay attention at these brackets, this is nothing but AB whole inverse equal to B inverse into A inverse. Without any trouble, you will be able to do this question. Okay. I think we have covered almost all the things for metrics. Complex numbers and functions. For complex number rotation, some questions I want to bring, but I think let's not do it today. Too long this session will go otherwise. Some more properties. Properties we did know. All these properties. Adjoints of A transpose is transpose of A adjoint. This property is very important. Remember this. Right. Inverse में some properties of inverse we did. I think inverse properties I didn't bring. क्या यार? Inverse properties I didn't bring. Inverse properties will be there in the lecture, the normal lecture which we have taken. Their inverse properties must be there. I should have bought here. Inverse properties also, some properties are very, very important, like this one. Okay. Rest everything is okay. Alright then, take care. Next session we'll come up with complex numbers, right? And for one session I'm going to bring on English channel only before 30th or on 30th or 31st. I'll come up with 200 questions which we will use to revise all the chapters. Not high weightage, low weightage. 200 questions I'll bring. In that, in the summary of those 200 questions, we'll revise all the chapters or complete syllabus of math. So please, I'll schedule that session on the channel also. Please attend that session, which will be very helpful. And with that one session, which will go somewhere around 12-14 hours, right? We might have to take 2 sessions. But in that, if that session you can attend, no, entire revision will be done. And you'll be very confident with your JEE Mains attempt 2 and even 26 or 27, whatever you're preparing for. Alright then, I'll take my leave. Thank you so much. Love you all. Keep preparing. Okay. Thank you. Thank you. Please don't forget to like the session and subscribe the channel if you haven't. Thank you.